now. And before we kick off, today is going to be primarily focused on a lot of the work that we're doing in the team domain, and a lot of work in support of the synthetic training environment. We talked about it briefly yesterday, but you'll get a lot more in-depth understanding today. We'll start with a good overview brief of our research program by Dr. Greg Goodwin, a nice kind of perspective on how we use GIFT to establish demonstrations to support our research needs, and then we'll have some really good talks on active research efforts to inform different adaptive training solutions for students. So I think the content's going to be really good. Before we start, one thing I wanted to do for those who are relatively new to the GIFT community, wanted to at least show you more or less how to get started and where to get started. So GIFT, like we mentioned yesterday, is an open source software project, and we host all of our public-facing content on gifttutoring.org. If you don't have an account, once you get to this webpage, you come to the top right corner and click register, and it'll walk you through establishing the username and the password. What's nice is once you have an account, you have access to all of the information and various content across this wiki framework. We have a very active forum where you can see for troubleshooting, we have 232 topics and over 1,100 messages within those topics, along with some good general discussion points. So for all you developers out there, if you're facing a challenge or you have a question, oftentimes someone else has experienced the same issue. So the forums are very helpful in that. It's also worth noting that we heavily publish. I came to realize yesterday that we're a little bit behind in updating some of our pubs, but you can come here to obtain all of the previous GIFTS user symposium proceedings. A little bit down below here, you can see 1 through 7. We also publish yearly design recommendation book series that cover a whole wide range of themes and topics within the adaptive instructional system space. We just released our 7th volume up here on self-improving systems. And the first 6 are down here. So you can see the 8th annual symposium and our recent book are both at the top. So I highly recommend checking those out when you get a chance. Once you also establish accounts, you can click on the Downloads tab, and here is all of the various materials that you have access to. The main source code released for GIFT, and I believe this just came out today. Mike, is that accurate?
Right now. Mike posted it this morning, and I made the announcement a little bit ago.
Okay, so we already have 2 downloads. So you can get the source code here, and there's a lot of supporting content up top. There's a nice description here. Some of them are example use cases, access to the media semantics server. There's a lot of goodness, and most of it is covered in the documentation. So that's the other thing I wanted to highlight. If you're back at the home page and you come over to this right panel, you see a quick start guide. These are some nice, easy access links. Click the documentation. You can see our documentation for all of the prior releases, and within there, it's pretty well documented. It's also worth noting that we do have a developer's guide as well that gets into more of the technical underlying architectural aspects of GIFT and what is required if you want to integrate with a new training environment or integrate with a new sensor or build a new assessment condition class. All of that is in there. And like I said, the forums are active, so we highly encourage your participation in those discussions. So with that, we ended yesterday. We still have a few minutes before we'll throw it over to Dr. Goodwin. Does anyone have any questions or open items that weren't resolved yesterday? All right. Well, that's a good thing. Dr. Goodwin, I think we can give you some extra time, which I'm sure you would never shy away from. So we can throw it over to you when you're ready.
Okay. Just want to make sure. Can you hear me fine?
Yes, sir.
All right. Okay. Can everyone see the cover slide for the talk?
I can, yes.
Okay, good. Yep. All right. Well, good morning, everybody. Welcome back to GIFTSYM8. I'm going to be talking this morning about giving you kind of an overview of where STI, the synthetic training environment development is right now. And then I'm going to be talking a little bit about how our GIFT and adaptive training research program is fitting into that. I think a lot of you know that we are very much aligned with the development of this training system. That's not to say that we're developing STI. What we're trying to do is do S&T to bring down risk in what we see as areas, technology areas that are critical to STI's success. And it turns out that, all the years we've been doing adaptive training, pretty much everything we did is relevant to the synthetic training environment. So it hasn't meant a major shift in our research agenda and program, other than I think we're focusing a little bit more heavily on use cases that have a military flavor to them. So anyway, so without further ado, let me just kind of charge into this. I'm going to start by talking a little bit about just some background on MDO, multi-domain operations, the CFT, how that fits into the CFT. I'll talk a little bit about STI design, and then I'll kind of get more into our, the relationship between our research program and STI. So this MDO concept is important because this is really one of the big drivers of the establishment of Army Futures Command. There's a lot to it, and you can read about it on the internet. Many of you have already read quite a bit about it. But it essentially is, it's been evolving over the last few years, and it's a combination of a couple of things. One is the realization that we have most of our weapon systems were designed, our major weapon systems were designed in the 1970s and 80s, and so they're getting really to the end of their lifespan. They've been modernized, of course, but we're seeing near peers like Russia who are beginning to develop technologies, bring warfighting systems out that we see evidence that we do not have a technological overmatch on the battlefield, and so there's a very urgent push to modernize the force. And then the other part of it is, watching near peer actors. We have seen that they use these other domains, political, economic, information, cyber, to gain strategic advantages without resorting to armed conflict. So, a perfect example of that would be the way that Russia was able to annex the Crimea Peninsula, essentially took it from Ukraine. And there was, NATO, there was no real military response to that because, Russia did not line up its tanks and roll through Crimea and in a large military operation. They did it using these other means, and effectively, Crimea voted to cede from Ukraine. Russia said, we will welcome you with open arms, and that seemed to be the end of it. So we realized we have to compete on this playing field as well, and so that's another part of MDO. So this slide here shows you the relationship between MDO and our Army priorities and cross-functional teams. This is this MDO concept of how we will compete in that multi-domain battle space. The Army priorities, long-range precision fires, the next generation combat vehicle, future vertical lift, and so forth, including the synthetic training environment down here, are what Army leadership has identified as systems that are critical to us being successful in that MDO fight. And then the CFTs, of course, were set up to essentially accelerate the development of these technologies by doing some rapid prototyping and by doing experimentation, bringing warfighters to the table to make sure that we're, really reaching out to industry and trying to leverage the, the latest and greatest that industry has to offer. And so that's really, what the STI is doing right now is doing this this prototyping effort, and we've been heavily involved in helping to define a lot of those requirements. So this is the STI vision. STI, where we are right now. So STI is really focused on combined arms collective training, and the technologies that we have right now are you'll see these terms and you've probably heard them a lot. They're stovepipes. So we've made them work in a distributed way, but they weren't really designed to do that. So it's kind of clunky. We have lots of different types of terrain. We have, all sorts of things that we have to overcome to make them work together. They're not, very little is automated, so there's a huge overhead. You need facilities, you need lots of contractors to make these things work. And the bottom line is the training system kind of almost gets in the way of training. I mean, there's as much, you have to, overcome so much just to do your training that, it's expensive and it limits the amount of training that can be done. And so the goal is to get to a place where, these systems are modernized. There's much more automation. They're naturally built to train in a distributed fashion. So they're very interoperable. We share data standards. We share messaging protocols and things like that. And we want to basically just step into have the warfighter step into the training without the enormous overhead that's involved. And this is just sort of an operational view of the synthetic training environment that essentially illustrates what I just said. They want to really train all the way up to theater level and all the way down to like the small unit squad level. Really all of these different domains, cyber, kinetic, you name it, and all manner of missions under MDO. All right, so I thought it would be useful to kind of share, this is kind of the STI framework that's been laid out. And so I put this on here. I showed you this last year. This is the STI framework circa 2019 and before. And, you'll see these components here that we'll talk about. There's this training simulation software, which is kind of the engine of, the simulation engine. The idea was that it would be kind of a game-based engine. This runs the virtual humans. It does all the semi-automated force driving and everything else. It works with this global terrain, this one world terrain, and it interfaces with these different training venues. So you can do staff training. We'll have like virtual and immersive training for like dismounts. So the soldier squad virtual trainer here. And then you've got, what's kind of considered to be also here the reconfigurable virtual trainers, and then even just kind of virtual semi-immersive training. So you'll notice training management tools is kind of like, we're sort of like on the outside looking in. We're not invited to the party in this vision here. There's this common synthetic environment that's sort of seen as the core of STI, and TMT is like this kind of plug-in. It interfaces with authoritative data sources, and it kind of helps do all the plan, prepare, execute, assess stuff. And then you've got live TADs are kind of outside of this, interfaces to legacy systems and mission command systems. All right, so this was the view before. And what that's evolved into is this more of a framework like this. So now they've come up with this concept of what's called the STI information system, or STIS. And you'll notice training management tools is we were now let into, the room. So we're now part of the popular kids club, I guess you could say. So it's training management tools, TSS, and one world terrain. And these are now really seen as the core elements of STI and the parts of STI that are being developed right now. There's been a recognition that training management tools is actually a very critical part of STI and a very central part of STI, because it really is the primary user interface for much of what you would do when you interact with STI. So in the planning and preparing phases, this is where you're identifying training objectives, you're building scenarios that you're going to use to train, you're configuring networks and configuring and training systems and getting everything ready to go. And then, in execution, you jump into TSS, you run your exercise, and then at the end, you come back out and, you're doing this assessment and after action review. So TMT is now seen as a very central part of STI. The other thing is, in addition to these sort of reconfigurable trainers and virtual trainers for dismounts, there's now an understanding that live training is part of STI, and that there will be this future live training environment, or LTE. The reason for that is STI is supposed to really be able to orchestrate training across live virtual constructive. So live training in this future live training environment is now seen as part of STI. Next generation constructive is something that's emerged as something that also is seen as critical, and that's part of STI. And those two pieces are really not, they will be developed going forward, but there aren't, the current status of STI, those are not parts of what's going on in STI right now. Those are seen as longer term kind of developments. And then we have these enabling systems. Of course, authoritative data sources, the Army network, legacy systems, live ranges, mission command systems that will have to interface, obviously with STI in order to deliver training. So, anyway, I'll pause for just a moment. I know I've been talking a lot. I don't know if anybody has any questions about what I've said so far before I start diving into the S&T side of things.
Hey, Greg, this is JT.
Yeah.
Can you say a little about who are the main performers on STI? or the main people we should know?
So currently, the main performer is VTMOC. They've been on the team. I guess they've been the main developer since last August about. And then they have a number of subs working for them, including Charles River, and let's see who else is. Actually, I'm not really sure who all their subs are other than Charles River. 4C is another one. They have developed this software called Exonaut, and there's a number of others in there. But yeah, those are kind of the main developers, and and I'll talk a little bit more about how we're kind of interfacing with them going forward.
Thanks.
Mm-hmm. All right. So some really good news this year. We are now in the process of integrating GIFT into the STI, the current STI, VTMOC's prototype. And to do that, we're developing what we're calling this headless GIFT, and it's essentially, it's not like a whole new animal. What we're doing is hiding some components of GIFT that you all are familiar with. So, for example, the tutor user interface will essentially be disabled or hidden because, the concept behind this is that GIFT is going to run as a kind of runtime assessment service inside of the synthetic training environment. So it's going to be able to do assessments during the execution of training. It will be able to, recommend interventions, but we're going to leave that up to STI to basically make the final determinations and have control over when those tactics and interventions are applied. So, GIFT normally is kind of running the show, and we're disabling some pieces of it so that it can essentially run as a service underneath this. The other thing we're doing is we're developing this in a system agnostic way. So we're remaining agnostic to whatever the training application is, and currently we're sort of agnostic to STI, who the STI performer is. Partly because it is, the STI is not, and the training management tools are really not mature enough for us to build any kind of interface with at the moment. And so, we have to remain a little bit agnostic there. And the other reason is, this whole OTA process, as you were asking, JT, the concept is for the OTA is you're building prototypes, testing them out, and your main objective is to understand what the requirements, how do we write the requirements for this system. So it's not a program of record right now. We're really technically supposed to be in a pre-material development decision phase. So it is possible that once those requirements are written, that there will be a new competition for award, and it could be VTMOC that gets that. It could be somebody else. We won't know until that time comes. So so we have to, we're trying to remain a little bit agnostic to that, and the way we're doing that is by essentially handling most communication through this messaging bus, messaging layer, and essentially, all of our requests for, runtime assessment, approval of strategies and everything goes through the message bus, and then any request for learner state, et cetera, also go through that. And I thought I would, I think Mike Hoffman is on the line, and I thought I would let him say a few more things about this, since he's really the primary architect of this.
Yeah, that was a good overview. Just a couple things. So I think in a couple previous conversations, we talked about how the Gift architecture can be switched between different deployment modes, whether it's a server mode or a desktop mode. This is very similar to that, where you can essentially put Gift into a different configuration, and then we've scattered so-called, if statements throughout the system that say, hey, we don't want to expose this component, whether it's a UI component or widget, or a certain module like the tutor module Greg mentioned. So these things can be very easily switched on and off if Steve or someone else that wants to use this headless Gift instance might want those features, but not the other features. So I think that's one important component here. Another thing that's Greg also mentioned was that we're not forcing Steve to take Gift. We would like them to use Gift. So this design that is on the slide is really that system agnostic design. So maybe the ITS Gift could be replaced in the future, or the message bus might change. Right now we're using ActiveMQ. It could be Pulsar. It could be RabbitMQ. It could be who knows what in the future. The test harness is what we can build today because we don't have a Steve vendor solution. But whatever that solution is in the future could also be replaced. The training application could be replaced. VBS, VR Engage, VR Forces, you name it. So what we envision here as essential is really what is passed between the systems, whether it's game state information, whether it's protobuf messages, trying to define that as a standard or as something that is accepted in the community is very important. So that could live on and evolve going forward.
All right, someone's got a hot mic. Might want to check and make sure you're muted. All right, so the other really good news I think for the community is that this really makes GIF now a potential transition target for you when it comes to transitioning things into STI. So we are, this isn't just going to be like a completely separate branch. We're going to try to maintain, we will be maintaining concurrency between our, what we're calling kind of the runtime assessment or RTA branch of Gift and the main branch of Gift. And so as we see, as we develop successful applications in Gift, that we want to start rolling into this, it makes it very easy for us to pull those things into our RTA version of Gift and therefore, transition them directly into STI. So we're really excited about that because that, as you all know, transitioning things over to any kind of, a program is extremely difficult to do. And this really eases that for us tremendously. So I think that's good news, not just for us, but for the whole community, really. All right. So I'm going to talk a little bit now about our research strategy going forward, and where we see things kind of playing out over the near, mid, and far term. As I said, we're not really trying to develop STI, but we're trying to, do S&T to address and bring down risk, mature, if you will, technologies that we see as really critical for STI. And so this chart illustrates some of that. Up at the top here, you can see the 4 phases of the plan, prepare, execute, and assess. And in each of those, we see, some really critical components of at each phase, being able to tailor scenario generation to the needs of individuals and units is going to be really critical. Providing real-time feedback and adaptation during execution. And then, of course, rapidly assessing performance, providing visualizations of data, and supporting AARs during assess. And as we all know, these are things that, problems that we've been working on for a while. the kind of core areas that we've identified. We identified 3 of these, and 3 of these I presented to you last year. It was really us, the material developer, and the capability developer, so the STCFT, and this was done back in 2018. And we really said, automated performance assessment for individuals and teams is going to be really critical. And these are high risk areas that we, especially at the team level, where we see a need for government investment in S&T. At the individual level, we think there's a number of commercial solutions out there, so we're focused a lot less on the individual level. Feedback and data visualization, and again, really the team level is what we see as the target of our S&T. And then intelligent adaptive training, right? And again, at the team level is where we're driving our S&T. This last year, we added another area that we think is critical, and Ben's talked a little bit about that already. This idea of competency tracking for individuals and teams, and that's really all about being able to see that team as they mature over multiple training events, both within and outside of STI. So how do we pull training data to identify a competency of a team, and then use that to tailor our training to that team, and track them over time, and even do forecasting and things like that of future training needs. So we think that's another key area, and that's something that's new this year. So this is a roadmap that Ben Goldberg and me and Chuck Amber, and we kind of brainstormed one afternoon and put it together. And this, you see those same 4 areas, automated assessment, adaptation and exercise control, data visualization and feedback, and then competency tracking. And we've tried to identify or describe, where we think the technology is going to be in the near term, kind of 20 to 22, the midterm, and then the far term, 26 to 28. And we think, so in the near term, we'll be focused more on small teams and very procedural tasks. Automated assessment, we think, is going to be driven by, really pre-authored scenario-specific metrics, because we know that as much as we want to have metrics that'll work on any terrain for any team, we know that that's still a very hard problem. And so you'll see in the near term, these things are more human expert dependent. So a lot of these are kind of pre-authored, rule-based feedback, event-based storyboard, OC dependent for data visualization, and persistent performance tracking maybe for small teams. In the mid and far terms, you'll see we're kind of getting away from these small team procedural tasks and getting into larger teams, like company-sized, and executing a more complex mission. And then in the far term, these much larger units with, teams of teams really, and joint combined arms, very complex mission space. And we're also hoping by that point, we have, machine generated metrics, right? Learning and AI that provides feedback and adaptation and exercise control, AI agent delivered, data visualization customized to the training audience, and we want these competencies to be really automatically generated and validated. So we're seeing that kind of progression, and I lay this out because it helps you see where we're thinking, and we welcome feedback if you think we're off the mark. It's something I think that's important to discuss, but it also kind of lets you know what we're looking to do as we go forward, and we of course welcome your ideas and proposals along those lines. This is a chart I showed you last year, and there's I really haven't changed much here, except that the persistent competency framework for military teams bullet right here was kind of brought down. It was kind of a neutral kind of ancillary project, and it's really now more of a core part, I think, of our research goals here. We're interested in both kind of the mixed reality visualization side of this, and as we've talked, we're building out a kind of TMT test bed where we have an interface between Ares and GIFT, and so we want to both focus on when we do feedback and when we do performance visualization, utilizing those kinds of technologies. And then, of course, the adaptive training side of things as well. And so these are problems that we see as critical to being solved. And again, that's we welcome any kind of proposals or thoughts on how we might address any of these. And that is my talk. I think I've got about 4 minutes left for questions, so I will open it up to the floor.
Thanks, Greg. Questions?
Greg, this is John Rowe. You mentioned earlier in your talk about training management tools kind of becoming, I think you described as one of the cool kids within the STEE framework. I wonder if you could say a little bit more about what you anticipate in terms of any implications for a community like this one of this shift over the past year.
Yeah, sure. So I think that one of the things that's really become a critical. So one of the shifts I think in the approach to building STEE that I've seen is there's an understanding that what the government really needs to be doing is defining defining message protocols, defining how all of this stuff is going to work together, defining those interfaces between an intelligent tutoring system and a training application, and other parts of STEE. So I think that development on that side of our research is also really critical, and that those are definitely research types of questions that a lot of you are asking. So I think that's very important. And anything that we can provide does have, I think, a high potential to impact the way that the system rolls out going forward. My hope would also be that that GIFT does actually stay in STEE over the long term, and then man, that would be awesome, because that becomes a very easy transition path for our S&T. It really greases the skids, as they say. As we develop things that we can mature and prove have validity, we can just roll those right into STEE quite easily, and I think that would be great as well.
This is Ben. I might have another little add-on to that. What's really interesting is the notion that they're embracing how training objectives are going to be running the show, and that there needs to be a strong presence of instructional system design and learning science and how STEE is used. So ultimately, if data is going to inform a lot of the practices, then they really need to consider how adaptive training and intelligent tutoring folds into the mix. And so from an architectural standpoint, they're now more than ever very cognizant of the training management implications when they make a change to the underlying game engine and things of that nature. So the training management tools will hopefully inform a lot of those requirements on what the game engine needs to do to support the training.
Yeah.
Hey, Greg, this is Randy Spain. I've got a quick question.
Yeah.
So I noticed in one of your slides you talked about kind of MR and mixed reality, and I didn't know if you had any thoughts or updates to give on kind of where do you see GIFT and maybe IVAS kind of coming together and playing a role in training?
Yeah, that's a really good question. So right now, IVAS is the integrated visual augmentation system. It is a operational system that dismounted infantry will use. So it's kind of a HoloLens like, heads-up display that infantry will use. And the idea, for those of you who don't know it out there, the idea is that it will also be able to be used in a training mode. And it's being developed by a separate CFT, but in that training mode, the concept is that it would plug into STI in some way. So Randy, to your question, we have not really been doing much research on, using GIFT in a mixed reality, infantry-centric kind of way. It is something, I think it is a need that's out there. We would definitely, and it is, I don't think it was something that I put on my, on that previous slide that had that had those little bullets on it. But it is something that's critical. We're the part of mixed reality that we're looking at is more in the Aries side of things. So, how could we maybe use that to provide feedback to leaders and teams at the end of training? But in terms of what would GIFT be doing during training, we haven't really gotten there yet. Part of the problem is, IVAS, we haven't had a lot of access to IVAS, so we don't know a whole lot about its capabilities. We haven't really had an opportunity to even attempt to do research with it, so that's part of the reason we haven't really looked at it too much. But it is an area that's important, I think. So probably maybe in future years that'll become something that gets on has a much higher profile on our roadmap.
Gotcha. Thanks, Greg, and super helpful demo. That was great.
Okay.
Presentation.
Thanks, Greg. So let's move on in the agenda. I believe next up is Miss Elise Burmester. She's been working on the GIFT team for the last 2.5 to 3 years and supports a lot of our development efforts in-house to get demonstrations stood up and things of that nature. So she's going to go through some of that process.
Can you hear me okay?
Say that again. You came through a little muffled.
Can you hear me okay? I guess that's a no.
Yeah, we can now.
Yes, we can.
Okay. So good morning. As Ben mentioned, my name is Elise Burmester. I'm a research assistant at DIGNITAS Technologies, and I'm going to present my workflow for authoring collective training demonstrations in GIFT. I've been on the GIFT team for about 3 years, and as Ben mentioned, I author a lot of the content for collective training demonstrations. And when I first started on this project, I had no programmer background. I, really didn't have an introduction to this system, and I was really thrown into it. And over the years, I've developed a process to effectively author these courses. I'm going to start by just quickly showing a timeline of how this authoring tool has been developed over the years. Then I will explain very high level the components of the DKF, the domain knowledge file, and then some of my recommendations, and then I'm going to actually jump into the authoring tool to show you what this process looks like. So from the beginning, 2011, GIFT was created, a prototype version, and it was just XML documents. It was all, there was no authoring tools. And then in 2012, in GIFT version 2.0, the first authoring tool was introduced. And you can start to see some of the components of the XML being exposed to the author. And then it went through several iterations of development, you know, eventually exposing more. In 2015, it looks a little complicated, and the 2017 version is what I actually started working on. And I thought that was great, but then we get to the revamp that happened in 2019, and this is a very improved version of the authoring tool. It's simplified, and there's a good flow to it, which I will explain. So just a quick overview of the domain knowledge file. This is the XML document that contains the information that will, it houses the assessment logic for your domain. It's authored with the DKF authoring tool, as I mentioned, and this is used in a number of training applications that GIFT has integrated with. And as I mentioned, I'm going to provide a very high level overview of the DKF authoring tool. There's a lot in it, and there's no way that I could explain all of that in 15 minutes. So I highly recommend, of course, checking out the documentation provided on gifttutoring.org for more technical information on the aspects that I'm going to explain. So I'm going to go through the next couple slides kind of quickly because they follow my process, and I'm just going to reiterate everything when I'm actually in the authoring tool, but I just wanted to show first what I will be in my process. So the four main components are tasks, strategies, state transitions, and assessment properties. The tasks are listed here. This is where you will list out all of the performance steps that you want to accomplish in your training application scenario. And there are the tasks have concepts that are associated with them, and each concept is assessed via conditions. The strategies are what instructional interventions you want to apply based on your learner's performance in the scenario. And I'll go through all of these in the actual tool. And then we have state transitions, which is the logic that will tell the system whether or not to apply these strategies that you've authored based on criteria. And then you have assessment properties, which there's end triggers, learner actions, places of interest, team organization, and miscellaneous. I'm going to explain the places of interest and team organization specifically, just for simplicity's sake. So some things that I've learned help me to author a course. Before I even get into the authoring tool, I outline first all of the tasks and concepts. So what tasks are the learners going to be responsible for during the training exercise? What concepts are assessed within each of those tasks? What are your intended learning outcomes or goals for each of these tasks? What are the thresholds that each of these tasks will be measured against. And then I also go down another level in this outline, and I try to outline what, based on good or bad performance, what actions should the system take to either reinforce the good performance or to correct the bad performance. And so outlining all of this ahead of time will just streamline the process when you are inside the authoring tool. Straight now.
Elise, can I ask a quick question?
Sure.
During your outline process, do you kind of map that out using like Visio, or do you use just like how do you best handle that approach?
So, I mean, I've done a number of different ways of doing this over the years. I started out in just Excel spreadsheets. Basically, anything that you can copy and paste from, I find easiest. I usually do the task and concept outline in just a Word document, honestly. It's just any way to visualize, the overall storyboard, if you will, of your scenario.
Gotcha. Thanks.
Hey, Randy, I think it's worth noting that Joan and Anne are going to be releasing a book chapter that kind of covers how to visualize your storylines for that authoring experience.
That would be really helpful. Thanks.
Okay, so once you've picked your training application that you want to use, I'm going to be using Virtual Battlespace. This is just what I have the most experience with, but the DKF is pretty much the same in all of the training applications, with a few, minor differences based on the application. So we're going to go ahead and author the real-time assessment. And the first panel that you'll see is the task list. So from here, you can take all of the tasks that you've already outlined and enter them in one by one. And I normally just dump everything in this list. You can then drill down, what are the concepts and what parent task do those concepts, should they be under? So let's say we have a room clearing scenario. So I'm just going to start with, let's say, clearing the room. So a concept that I would want to assess my learners on for that would be to maintain their sectors of fire. So once you've created a concept, you then link it to a condition class, which these are all of the options for VBS. And as I mentioned, these are going to vary depending on the training application that you choose. And I'm not going to go into too much detail of this because they're all very different, but basically this is where you, for this I would do muzzle flagging. This is actually one of the new condition classes created that will check, I think Ben mentioned it in his presentation, checks to see where the learner's orientation, where their weapon is pointing, to then check whether they're violating another team member's sector of fire. So this is the area that you will input all of the different metrics for your conditions, and it varies per condition, but it's all pretty well explained in this description. So once you have this populated, the next step you need to take is to define the task lifespan, which is there are start and stop triggers, and these are going to tell the system when this task should be activated and when it should stop. And the concepts underneath that parent task will only be active during the duration of this task's lifespan. So once you have your task list populated, I usually move on to the strategies. And this is going to be kind of what I call the strategy state transition loop, because they're intertwined, if you will. So first, you want to input a new strategy. So let's say I want to, send feedback to correct a learner that is not properly maintaining their sector of fire. They flagged another player. So you go in and choose an activity. Your options are either instructional interventions, which include feedback, presenting feedback to the learner, or presenting media, which could be a PDF, picture, what have you. Or you could modify the scenario, which has several different options. This will change the simulated environment. So if you wanted to increase difficulty by creating actors or making it, increasing the fog, several different options. Or you can present a survey or start a conversation. So then once you have a message authored, you then link it to a state transition using this button down here. So now within the state transition panel, you want to author the logical expression that will define what change in learner state will send that strategy to the learner. So you can do this based on either an authored task, an authored concept, or a possible learner state, which can be dependent on sensors or other things. So let's say I want to do a concept, my maintaining sector of fire. Then you define what change you want the system to pick up on to apply this strategy. So since I'm trying to remediate poor performance, I'm going to say whenever the learner's performance in this concept changes from anything, anytime it goes to below. And then that state transition strategy loop is complete, and it is linked back to this concept that you've authored. So that's the main portion of it. And you just iteratively go through and add in your strategies, connect them to the state transitions until you have a good flow that you want for your domain. Then I go into the assessment properties, and I'm not going to touch on all of these different sections, but the two main ones that I want to focus on are places of interest and team organization. So the places of interest, this is where all of the important locations within your simulated environment are. That can be a point, a path, or an area, and they are defined using the coordinates from the training application. These locations can then be linked to tasks, concepts, and conditions to specify, if there's a location that you want your learner to avoid and you want to assess their performance on avoiding that location, you would connect it through there. And finally, the team organization is a new addition. This is where you will list out teams, sub-teams, team members. The possibilities are endless. You can fill this with as many entries as you want. This will identify the learners in your simulated environment or your training application. And these are identified by either the start location of that entity in the VBS, for example, or the entity marker that you've authored in VBS, which is the URN marking in that case. So just some way for GIFT to pick up on which entity you are using in the training application. So then once you've filled this list out, you can connect a learner to a concept or condition, which will specify individuals or teams that you want to, be the only ones that are being assessed for that certain condition or concept. Oh, and it's right here. So this is where you would link, which team members should be assessed.
Elise, do you have a fully populated DKF that you might be able to show if you have time?
I do.
And then also, there's a lot of moving parts. So if you were originally new to this process, do you want to touch a little bit on how you iterate over, putting all these inputs in and then testing it and then coming back? How do you do that? What's that process like?
Right. So that's my last step that I was going to cover is testing this all out is going to be a process in itself. It's most likely going to take several iterations of actually running your course once you've got everything inputted, running the course with the training application, going through and making sure each trigger happens at the right time, each assessment applies the strategy that you wanted. It's just testing it over and over and then going back and tweaking the DKF to fix whatever might have gone wrong, So this is a DKF that is pretty much fully populated. I mean, it is fully populated. So you see the tasks and concepts. And then the different strategies that will be applied. And the associated state transitions.
So this is Ben. I think one really important aspect to keep in mind here is that everything that Elise built. Can you go back to that task model on the left? So this in some sense is linked to doctrine. I don't know if this is fully, but the intent is for these task models to be linked to something that came out of TRADOC or whoever the proponent is that's guiding the training. So this can be, in some sense, a template for this specific task that could be executed in any given situation or any given terrain. The challenge that is faced at the configuration level is then contextualizing this task model with the environment that task is actually going to be executed within. And you also have a lot of flexibility here because you can definitely build out very unique and robust assessments. And it becomes more of an art than a science. And this is intended to be a back and forth between a GIFT developer, quote unquote, and a subject matter expert or training developer, so that you can make sure that your scenario has all of the proper events and triggers to train the objectives, and then you have the proper contextualization to determine their performance.
So pretty much covers it. That's a good wrap up from Ben. Anyone has any questions? All right. 4 minutes left.
Yes, I have a question. Thank you. This is really helpful. My question is, I see under the organization, you got the team and the individuals. Do you have any difference when you come to assessment for the competence of a team or the competence of an individual, or your interface is the same?
So I'm going to direct that question to either Ben or Mike. I'm not as familiar with the competency side of things.
Yeah, here you see you have individual, you have team. Yeah, to see if you come to the assessment, do you do it the same way or you have to do it differently?
So I believe,
from the technical point of view.
I believe, and Mike, you can correct me if I'm wrong, when you are at the task and concept level, you can either assess that as a kind of holistic team level task that if the objective or the end state is observed, then that team state is credited for that performance, or you can assign subtasks or subconcepts to specific individuals so that you are designating that for this given aspect of the scenario, these individual roles will be responsible for completing that portion of the assignment.
Yeah, that's true. And you can also, you can take it a step farther, and in the state transition, the state transitions that you author, you can define that, say, maybe a particular feedback is only for experts or novice or journeyman in a particular concept. So, and you can also, take it a step further and say, okay, well, highly motivated novice learners being assessed this way will get this type of feedback. So you can start combining different permutations of state information that GIFT can collect based on your situation, whether you have sensors like physiological sensors attached, or you have survey state information that's assessing an individual based on responses, and you can combine this into a more complicated set of strategies.
And it's worth noting that we do have a new project that's kicking off, I believe, in a week, that is focused on really extending out that understanding of the question you just asked.
Yeah.
And it will be at the scenario level, and as Greg mentioned in his previous discussion, at the persistent level, because especially at the team performance kind of dimension, we're very curious to see how performance improves over iteration. What differences are we observing in your behavior from scenario 1 versus scenario 5, and where do we see those improvements in between, so that we can start to ascertain, when you start to plateau and when challenge needs to be increased. There's a lot of interesting questions that we're going to address.
Well, thank you. I think there's a lot of implications here. You definitely technically you can treat the individual team in the same way, but there are some summative. A team can add the individual capability to aggregate their competence. So it is a matter of where you're going to build those facility to help to to sum up all those individual capability into a team. So you do not need to do it one by one again by hands when you do the inputting or assessment. That of course is an implementation issue, but it's a complicated one.
All right. Yeah, I agree.
Yeah.
So hopefully we will have more to discuss a year from now at GIFTSYM8.
Thank you very much.
Any more questions? We're right on the edge of a break. I think we have time for one more question if there's one out there.
Hey, this is Greg. Elise, how long, there's this, obviously it's a very iterative process, but about how long did it take you to build the DKF that you're kind of showing us here?
I would say this took, once you have everything outlined, it definitely takes like a couple hours to fully fill out this DKF. But as you mentioned, the iterative process, that takes, usually a couple days, or it depends on the level of difficulty of your DKF or how complex it is. But yeah, I would say like a day-ish.
I think the one challenge that we've found when it comes to testing a team-based scenario is a lot of the development is by one individual. So to test can be a challenge. So there's been some interesting workarounds to be able to stimulate GIFT with team data for one individual testing those files, if that makes sense. And you can reach out to Mike and Elise if you want to find out more information on that. Okay, thanks, Elise. Good job. So we have a 13-minute break. We'll reconvene at 10 o'clock Eastern Daylight Savings Time, EDT. We will then be on the home stretch. We have 4 more talks, and they are all very keyed into the research topics that Dr. Goodwin presented in his briefing. One of them will be very focused on team development through coaching strategies and applying reinforcement learning techniques. And then the other 3 are really looking into the automated assessment space and all of the nuances that go into that at the team level, both at the kind of physical movement as well as the communication aspect. So a lot of interesting stuff. So come back at 10 o'clock. Elise, can you put up that we're on break slide, please? Well, I'll give a 1 minute warning shout out, and then we'll kick off the last round.
Great.
Okay, we'll fight and stay on schedule. Hope everyone had a good break. So we are starting off the last session on day 2. We have an all-star lineup, and we're going to kick it off with JT Folsom Kaverick. Take it away. If you hear a bell, that's your 5-minute warning.
Thanks, Ben. Can you confirm you see my slides up?
You're good to go.
Great. All right, so hi, my name is JT Folsom Kaverick. I'm a senior scientist at SOAR Technology. And I'd like to start off by saying, I really appreciate getting to see everybody, a lot of familiar faces again after a long period of time in these last few days. So thanks to the entire team for getting this virtual conference together. It's been great. During this talk, I'm going to be presenting work that we're starting at SOAR Technology in collaboration with STTC on automating assessment and feedback for teamwork to operationalize this concept, team functional resilience. So this work is work that is, got a large cast of characters over at SOARTech and STTC. And I'll name Joel C. and Denise Nicholson especially. In addition, Ann Sinatra has been giving us guidance along the way at every step in how to assess teamwork and how to present what we're working on in a way that's going to be valid to soldiers. So on this slide, I'm looking at kind of a quad chart, right? A quick summary of what I'm going to cover. And we are really focused on automating team assessment to further enhance what has already been presented in GIFT and what's already been done by Dignitas and others to assess teamwork. And the way that we want to do that is we want to focus on linking individual contributions to overall team performance. And we want to talk about assessing team functional resilience as a way to give our work focus so that we're not trying to take on the entire world of team assessment all at once. And I'll talk about team functional resilience on the next slide. Some of the technical challenges that we identified are really figuring out what are observable behaviors that can be linked to this higher level cognitive skill of a team, trying to create assessments that work across several conditions as they interact. So I use the word condition to refer to a GIFT condition rather than an experimental condition. And finally, a challenge in the scalability of expressing conditions so that they can be effective in a number of different scenarios or settings, so that they're not, taking one step, right? Taking one step toward conditions that can be reused in many different scenarios. So our approach was focused on enhancements in GIFT conditions. And we'll talk about that further on a number of slides. So I'm going to just look at this picture in the bottom right. In the bottom right, we see a storyline that tells what we are trying to do, right? And it plays from left to right. And in the left picture, we see that we have team training, and some individuals or some teams within the training scenario are not performing a function. In the second picture, we detect a corrective action, and we're able to record the corrective action and link it back to the failure that made that correction necessary. And finally, especially in future work, we want to use this information about team functionality to keep training on track, tailor the training to repair functional failure and support instructional intervention in real time. That is a future work, because in our current effort, we are focused only on after-action review. So, team functional resilience. So I'm going to give you the 1-minute version, and the 1-minute version of team functional resilience is that this is a team cognitive skill. It is a complex skill, which means that it's requires a number of different cognitive abilities to be recruited and applied correctly. And the basic idea is that we have roles in teams. GIFT already knows about roles. And, those roles can be, for example, your job title, right? You're the squad leader, your job task, your equipment, like, you're the person who's carrying the mortar on the team. But roles can also be a number of additional facts about a learner. So, we could be talking states and traits of the learner. We could be talking assignments that the learners received during the scenario, and we could be talking, things that the learner knows about, things that the learner, has facts about them in the world. Each of these roles carries with it a responsibility, and so we talk about team functional resilience in terms of individual team members carrying out responsibilities, or should that any failure or loss of one of those functions occur, then different team member, or I assume the same team member later, carrying out a corrective action, right? So a corrective action for the purposes of this project is going to be carried out within the team, is going to be carried out after the fact of a failure, and is going to be carried out during the same scenario. So obviously in future work, we could say, there are many additional types of repair which are beyond corrective action, such as prevention. And so there's a lot of room to continue this work going forward, but this is our focus right now, is identifying a specific functional loss and linking that to a specific corrective action, so that we're able to make an assessment about the team, which links back to individual actions. On this slide, I'm looking at some various understandings of team competencies, and I highlight on this slide the rightmost column, which represents our focus on this project, team dimensional training. Team dimensional training is a framework for understanding teams that provides us with a number of benefits that I'll talk about in a later slide. And the key dimensions in the framework that we're using are those four on the right, called information exchange, communication, supporting behavior, and initiative or leadership. So what we're trying to do is, having identified specific conditions that apply to a specific scenario, we want to then say how those link back to a general model of team performance, and so that we can provide adaptive after-action review to the team and say, you know, you as a team are displaying these 4 dimensions, you know, information exchange, communication, supporting behavior, and initiative or leadership. So these are team dimensions that we're assessing. I have several slides that are kind of like a little quick animation here that talk about how we're linking individual contributions to the team's performance. So at the top of the slide here, we can see an example of a team competency drawn from those 4 that I named before, where I said, you know, maybe we want to study information exchange and initiative or leadership. We want to work that down to, you know, at the bottom row, what are the specific things that we're going to be looking at to make that team assessment. So the first step that we want to say is how do we express information exchange and initiative leadership in a specific scenario? In an infantry scenario where we're, you know, carrying out, you know, movement to contact and other tasks that are familiar from previous talks this last 2 days, we can see that there are, you know, specific things that we could be looking for, and we've made some examples that we're going to talk about in this half hour. So a domain general measure that reflects some of those team competencies might be time from role failure to role replacement. So we want to then say, you know, we've got this knowledge that was given to us from experts in team training that these dimensions are, you know, important to a team, but also that they are expressed in this measure, right? That, you know, how fast can you recognize that there was a failure, identify the correct corrective action, implement the corrective action, and we want to then further trace those down the rows, right, to the next level to say what are the individual contributions that are going to be measured here. So each of those individual contributions is, you know, on the left-hand side, there's a specific team member who's in a compromised role, and there's a replacing team member, the one who carries out the corrective action. And then, you know, down at the bottom, we've got these domain-specific observations, which are saying, you know, what are the specific actions that tell us that a role is compromised, that, you know, a function has not been carried out? And what are the specific actions that indicate that the role was replaced, that is, a corrective action was carried out? So the bottom level is a condition in GIFT, and the top level is a team assessment in GIFT, and we're going to be able to link all of those together in this project. So you know, the first step here is, you know, we recognize that the conditions are the GIFT conditions are monitoring performance, right? We recognize that the assessments are then linking the monitored performance into you know, what should be done, an expert model of, you know, what is the expected behavior. And then there's this level called diagnose, which refers to some number of inferences. So there's inference that says, you know, given the information about the team members' roles, given the information about the expected function and the actual function, what is the inference we can draw about the team competencies? So I'll next say that, you know, there are a few technical points that we want to add to the GIFT architecture. And in our current work, we're focusing on the GIFT condition class to make these changes. So in particular, at the top, the first one is we want to have relations between conditions. We want to have relationships that let an assessment cross over an event boundary and link together conditions in time. Second, we want to know about context. We want to know that kinds of information that is usually in an ITS expert model, such as who should have done this, who should have carried out the replacement, and so forth. And I'll point out that that level of context is the level that's available in the scenario, as opposed to context such as, what did people have for breakfast? Are they fatigued? That kind of context is outside of our scope. And finally, there's some level of memory. For example, in this particular story where we're looking at a person carrying out a corrective action, we need to know, who was the person that was originally in the role and then the role changed. So we've got this idea of a history that we're going to be adding. So that motivates some of the technical challenges. On this slide, I'm going to give just one quick overview of team dimensional training, because this has been well studied over the course of decades, right? Team dimensional training was originally came to us from the TADMAS project, which many of us in this field will remember is related to team decision making in the AGIS system specifically. TDT, or team dimensional training, has also been tested in many other environments, including other Navy environments like subs, including other work like medical field. And so just to tell you a little bit about what TDT gives us, TDT gives us recommendations about how to deliver training, right? It gives us recommendations about measures that we should be offering. And it gives us a focus on competencies that are related to teamwork as opposed to task work. So we've got this idea that the GIFT competencies should be reusable, should be general across scenarios, and we are going to accomplish that using the TDT framework to make sure that what we do is highly reusable and not specific to the example that I present today. Finally, there are a number of instructional recommendations which come to us from TDT. These instructional recommendations are really going to help us when we get into presenting the outcomes of our assessment in an after-action review. So our focus is on assessment, but we are going to close the loop and we are going to present the assessments to a leader in a supporting tool that says, here's how to do after-action review. And that's really going to help instructors we've got good feedback on this so far. Expert instructors will get help to catch events that happen very quickly. In an infantry scenario, we could be talking about, a few seconds for a loss of function and a recovery of function in the team. And for those instructors or leaders who are presenting AAR but are not so expert in the structuring of the TDT, will really help them to make sure that they focus on process rather than outcomes, and make sure that they are talking to everyone, not just picking on someone in the team, and eliciting discussion and so forth. So I'll real quickly talk about one of our example scenarios. We want to present a team training scenario for a squad of soldiers. Most of this squad have deployed together before. And the goal of this training is to integrate new members into the squad and introduce them to collective training tasks. There is a squad on patrol. While they're on patrol, they receive communication that there's a high-value target present in a nearby building. They're going to first move to contact when approaching the high-value target building. Right? They're going to demonstrate coordinated action, and this coordination is different from what GIFT can already evaluate, because existing GIFT conditions will look at a single action at a time, right? So it'll be the moving action or the looking action. You know, is everyone looking the right direction? Are you covering 360 degrees? Whereas the work that we do is specifically created to require coordination across those actions, right? So we need to say that, you know, this guy is looking while that guy is moving, right? That's a new technical capability. Second, the team will enter a building to capture the high value target. The existing room clearing scenarios, which you've seen in several presentations during the last 2 days, will be enhanced with multiple variations on what is inside the building, right? So we'll be able to say, you know, our conditions work under a number of different scenarios. It's not just built for this scenario. And, you know, if you decide to throw in extra hostiles, then the same condition will still work. All right. Due to time, I'm going to quickly press on to the last few slides here. Looking at this slide here, we have an overview of the places where Sortech proposes to make changes. I'd emphasize that these are proposed changes and not available to the GIFT community at this moment, because they're in an experimental branch. However, one valuable point of this talk is to collect information or feedback from you in the community about these changes that we're talking about. So we're talking about introducing into the condition class a role manager, a state manager, and a number of queries about historical context. First of all, out of those 3 points, the first point is expressing individual contributions to team roles. So roles already exist in GIFT. They are currently limited to a hierarchical view, and we introduce a new structure for roles, which allows them to be many-to-many. Which means that it's no longer the case that it's, you know, team member is in a team, is in a larger team. Instead, you can have one team member with many teams, or one, with many roles, or one role with many team members. So it's a many-to-many relationship there. The resolution of a role to an individual is based on the existing team role work that has already come from Dignitas. Looking at the responsibilities, what I'll say, because of the short time, is that we really want to enable the same condition to work in many different situations. Therefore, we have introduced this idea of an overlay, which tells us which responsibilities are in effect at this time. The overlays are, you know, if there is a hostile enemy present, then it turns on certain responsibilities, and it turns off certain other responsibilities. And these are processed as the state of the world changes, which leads me to this next slide, talking about corrective actions. And what I'll say to summarize this slide quickly is that there are interesting facts about corrective actions, such as there are some good ones and some bad ones. There are optimal and suboptimal corrective actions. And we currently can detect the difference between optimal and suboptimal based on these differences. What was the action taken? Who took the action? And when was the action taken? On this next slide, we're looking at the second enhancements that we propose. We're looking at conditions communicating with each other using a shared knowledge of world state, which is a familiar technical approach that many of you should find approachable, called a whiteboard. Used to be called a blackboard, where conditions are able to write what they know to a whiteboard that everyone can read, right? It's globally available to all conditions. This gives us a new ability for conditions to specify in the DKF where they want to look for knowledge using a key value structure. And the keys and values that they look up will tell them facts about the world that they don't have to collect in real time. This helps to shift the gift condition structure, which is currently highly focused on events. It's event-driven structure, to events plus existing state. The conditions no longer need to maintain all state themselves. They now can talk to other conditions to get state of the world. Finally, the third point that we want to talk about is the adaptive after-action review support. So we currently have this history of world state, which is different from the timeline that is presented to, for example, the observer, controller, trainer in the game master view, which is already in GIFT. The difference is that this information is for internal processing. It is not necessarily presented in chronological order, and instead it informs this prioritized feedback, which is currently in the design phase. So the design candidate on the right gives you an example of those kinds of prioritized feedback that help you to, as a team leader, make sure that you cover all 4 dimensions, make sure that you say both good and bad things, things to sustain and things to improve, and make sure that you talk to all the team members rather than picking on the person who did have a lot to talk about. So this AAR support, using the new world state and using the new history of world state, which is collected, will be able to tell you information about who was in a role, what functions or responsibilities they were expected to be doing, and who was doing those functions instead if there was any corrective action carried out. I will end, because I see I've got 4 minutes, with some next steps. One next step is we would like to be able to directly observe team process rather than infer it. Currently, we can only observe actions within a VBS scenario, and we would like to add, observations such as speaking, utterances between the team, based on existing research that is kind of hinted at in this slide. We have this team communication evaluator. In the near future, we hope to make the roles dynamically bound, so that we can move past what is the current DKF structure on the left, which says, in simplified version, it's not the real DKF. We have to statically say, learner 1 is the guy that's driving vehicle 1, and that has to be known at the time the DKF is written. We want to instead say, we've got a variable for a vehicle, we've got a variable for a driver, and we're going to make those assignments in real time. Finally, in the near future, we also want to look at scaling this up to much larger teams, all the way up to battalion size. And we know from past experience that a number of if-then statements is going to become, inefficient with a lot of conditions, right? When there's a lot going on in the world, and when there's a lot of possible assignments. That is, when there's partial matches of roles to learners that we need to evaluate many partial matches. Under these conditions, Sortech has had a lot of success with our REAT algorithm, which is the core of the SOAR cognitive architecture, and in future work may be incorporated into the evaluation of gift conditions. So in conclusion, Sortech is working to assess team functional resilience and provide after-action review support. We're linking individual contributions to team performance. We're working across gift conditions. we are automating team assessment for some challenging expressions that we chose to kind of stretch what the technology can do and give us an opportunity to make a technical contribution. And we're really focused on making the DKF authoring scalable and reusable. In conclusion, I'm definitely open to discussion, either immediately or by email afterwards, about the work we presented and how we can move forward in the GIFT community. Thank you.
JT, we have time for a couple of questions.
Great.
We're pressing.
JT, this is Randy Jensen. First of all, this looks really good. Can you hear me?
It's a little garbled. Go ahead.
Okay, sorry. Well, anyway, it looks really good. Good presentation. I was just curious, when you were talking about, when you showed the slide with sort of the link from team performance from domain general down to domain specific.
Yeah.
And sort of what you're proposing, are you thinking of sort of explicitly representing each of those steps all the way down, or each of those levels?
Yeah, good question. At this time, some of those are not explicitly represented, and instead those inform the design of the conditions. In particular, there's not currently a link that goes all the way up to team competency, because the team competencies are right now only within our specialized after action review tool, and they're not in the GIFT world. So going forward, we want to have that link moved into GIFT and made part of GIFT. But right now, the links that are already in GIFT are the conditions and the assessments.
Right. Okay, thanks.
So I said a couple questions, but I'm going to cut you at one question. If you have any other comments or questions for JT, either hit them up in the chat or maybe go to your last slide and show your email address one.
Great. All right, here's my email address, Jeremiah. JT is short for Jeremiah.
All right.
And look forward to it. Thank you, guys.
Okay, so moving on, our next speaker is Dr. Jonathan Rowe out of North Carolina State University. I believe the next two talks come from that team. Take it away, John.
All righty, thanks, Ben. Are you seeing my screen?
You're good.
Okay, great. Well, thanks very much. My name is John Rowe. I'm a research scientist at NC State University, as Ben said, and I would like to echo JT's remarks at the beginning about just being really pleased to have the opportunity to speak here at GIFTSYM and participate in a virtual GIFTSYM for the first time this year, given the current circumstances. It's just really great to be able to be resilient and have this gathering this week. So today I'm going to talk a bit about a new project that our team is working on, including colleagues at NC State, Randy Spain, Brad Mott, James Lester, Bob Picorni, and his team at Intelligent Automation in Maryland, and Ben Goldberg and colleagues at STTC in Orlando on data-driven models of team feedback in simulation-based training environments with GIFT. So this is the team portion of the GIFTSYM program. So I probably don't need to say a whole lot about the significance or relevance of teams or team training for this group. But I will kind of say that feedback is a really important issue and kind of topic in this area. So feedback is really part and parcel to intelligent tutors and adaptive instructional systems. in terms of what makes them effective. And we know from kind of a long record of research that feedback is really critical for learning. It effectively helps learners know where they're at, helps learners evaluate their progress and performance, and identify where they may have gaps or misunderstandings in their own knowledge, and support improvement in learning. And particularly in the AI in education and intelligent tutoring systems communities, there's been a lot of work on computational models of feedback, but a lot of that work has been pretty squarely focused on the context of individual learners. And the shift or the presence of multiple learners by a focus on team-based training really introduces a number of new opportunities and challenges and just really interesting research questions about how to most effectively deliver feedback automatically in a range of learning environments, including simulation-based training environments. And it's this issue that our project is really focused on investigating. So the project, which we're still in the pretty early stages of, is called Team Coach. And the objective of the project is to devise and investigate a data-driven pedagogical planning framework for delivering feedback at runtime during team training tasks in simulation-based training environments. So we're really interested in leveraging machine learning to be able to induce automated models for making decisions about feedback to help support effective team training. This slide provides kind of a conceptual overview of our approach to Team Coach. So you can kind of see on the left here, we have this kind of unit of a team of trainees interacting with a simulation-based training environment. You can imagine something like a virtual battle space type of simulation. And these interactions, these training exercises are instrumented kind of by nature of being in the simulation-based environment, and the data that is produced from these team training interactions can serve as effectively the raw material for machine learning, for inducing models to drive decisions about how to provide feedback to individual learners and teams. And the vision is to be able to integrate these machine learning based models back into a runtime system, into the adaptive instructional system or intelligent tutor, to drive decisions about when and how and what types of feedback should be delivered to support and enhance the effectiveness of these team training exercises. So in the talk today, I'd just like to kind of describe a little bit about some of the foundations and prior work that we're building on for the Team Coach project in terms of delivering feedback for teams and kind of building on prior work on data-driven pedagogical planning. I'll say a little bit about some of the new features in GIFT that we're looking very closely at in support of this effort and plans moving forward. And I'd like to share some of the requirements and themes that have emerged in our discussions and planning for creating these types of models that will be driving a lot of our work moving forward, and that have really kind of come out from focusing on what would be involved in integrating data-driven models, specifically of team feedback, into a generalized tutoring framework like GIFT. And then I'll conclude with a brief discussion of future work. So as I mentioned before, there's a rich literature dating back really several decades on feedback and the effectiveness of feedback and delivering feedback in simulation-based environments. including specific research on the content of feedback and when feedback should be delivered and how should feedback be delivered in terms of modality. And kind of the summary is that feedback works. It's important and effective for supporting learning and performance and transfer. But the way that you deliver feedback, how the feedback is delivered, really matters. And adapting feedback can have real effects on the effectiveness of the learning that it's intended to support. So actually, my colleague Randy Spain wrote a nice book chapter on this topic if anyone's interested. That's just kind of a survey of some of the recent literature on feedback in game-based learning environments that appears in the recent handbook on game-based learning that Rich Mayer, Jan Ploss, and Bruce Homer edited. So if you're interested in kind of some of this literature, Randy has a nice chapter summarizing it. It was kind of released about a year ago. So this second kind of really key foundation to our work here is, of course, work on the science of teams and team behavior and the development of teams. So naturally, the measurement and assessment and understanding of what makes for effective teams is really critical for informing how ought we then to deliver feedback to be able to support the development of more effective teams. And one of the observations from really beginning to look into this literature is that there's not yet really much in the way of prescriptive guidance about how feedback should be delivered at runtime for teams. There's just a lot of foundational challenges in terms of measurement and challenges in terms of availability of data that are major issues in this area. And so there's an opportunity, we think, to be able, both in investigating how to devise models of feedback, but also to leverage a data-driven approach to inform how feedback can be delivered to teams. So as I mentioned a bit earlier, a lot of the work on in like AI in education, intelligent tutors on delivering feedback has really focused on individual learners. And the transition to teams introduces a broad range of considerations that are important to inform how feedback is delivered. Both what is your model of what makes for effective teamwork, and what is the model of team development? How do different stages of team development shape how feedback should be delivered? If you're working with either a new team or a team of novices, how should feedback differ compared to both with respect to timing and content and modality, compared to feedback that would be provided for an expert team that's already is highly cohesive and resilient. And similarly, a lot of this can be shaped by the specific targeted training outcomes and domains and kind of the phase in which a team training exercise is occurring. So there's a lot of richness and complexity that's will be key to consider in how we devise these, how team feedback is delivered. So our work in this area is an extension of, or I should say a continuation of a line of research that our group has been very interested in over the last several years on data-driven pedagogical planning. Ben has alluded to some of this work earlier in the symposium, but by pedagogical planning, I'm really referring to the component of an adaptive instructional system or an intelligent tutor that makes decisions about providing hints or feedback or assessments or remediation to be able to support learning outcomes. And it's data-driven in the sense that these models for driving these pedagogical decisions are created or induced using machine learning or data mining techniques. So for several years, we've worked with Ben and colleagues at STTC on looking at using reinforcement learning techniques to induce pedagogical planning models for individual learners learning in a course on counterinsurgency training. This work has focused on making decisions about delivering remediation at runtime, shaped by Mikichi's ICAP framework. So making decisions about what types of feedback in terms of whether the student should engage in constructive or active or passive learning processes with that remediation and feedback. And those decisions, those pedagogical decisions are driven based on policies induced using reinforcement learning techniques. So data-driven pedagogical planning and particularly reinforcement learning-based approaches have received a lot of attention in recent years. If anyone has been to the AI in Education or educational data mining conferences in the last couple of years, there's just been this really noticeable uptick in interest in reinforcement learning techniques. And the community's been making real progress in this area, both in demonstrating the use of reinforcement learning to induce pedagogical policies for a number of domains, as well as using a range of reinforcement learning techniques, from deep reinforcement learning to hierarchical reinforcement learning and multi-objective reinforcement learning, as well as addressing some really thorny problems in this area, including credit assignment and offline policy evaluation and other issues. So it's an area that's making some real progress. But again, like a lot of the literature on intelligent tutoring systems historically, there's been a strong focus on individual learners. And the introduction of teams introduces a lot of complexity with regard to how these reinforcement learning models are formalized and created, including the state representation and actions and rewards that have to be defined to formalize a reinforcement learning-based pedagogical planning problem in order to capture the increased complexity that comes from the presence of multiple team members. And this will be a kind of a major focus of our work moving forward in the project. So I just got the bell a minute ago, so I'm going to kind of hurry up to make sure to finish my talk on time. So moving forward, we're looking very closely at some of the new human-in-the-loop adaptive instruction features in GIFT, including the GIFT Game Master, which we've heard about a few times so far in the symposium. But one of the things that we're really excited about with this capability and looking at it very closely with is that it both enables a human instructor or observer controller to be observing and monitoring a team training exercise and performing assessments and providing feedback. But because it's mediated by GIFT, the entire process can be instrumented. So we can get this really rich data on how human instructors provide feedback and coaching to GIFT. It's our hope we can use that to inform the creation of data-driven models of team feedback. The simulation-based training platform that we're using for this work is Virtual Battlespace 3, which for anyone who's not familiar with it, is a very popular simulation-based training platform that has broad support for a range of collective training tasks. And already there's kind of extensive integration with GIFT. And our initial task domain that we're looking at is actually crew gunnery skills training. We're in early conversations with folks at the Warrior Skills Training Center, or WSTIC, at Fort Hood, which helps facilitate training for really large kind of throughput of soldiers across a range of tasks, including crew gunnery. They support a number of different types of vehicle types with crews between 2 to 4 soldiers at a time. They make really extensive use of Virtual Battlespace 3 for this training. So we're optimistic and about being able to work with WSTIC to be able to begin collecting some data about effective team training in this domain. So as we've been thinking about, engage initial discussions about developing data-driven models of team feedback and coaching in GIFT, a number of requirements and themes have emerged. I'd like to share 3 of these in the remainder of this talk. So one is the importance of aligning approaches and methodology for creating data-driven pedagogical planners with the learning effect model, which is really integral to GIFT's architecture and how information flows in GIFT. And I'll say a little bit about that in a minute. The second kind of major theme that we've seen or that has come up in our discussions is the importance of the exploration exploitation trade-off, which is a really fundamental issue in reinforcement learning and will be important in the creation of data-driven models of team feedback. And third, the opportunity for enhancing tools and workflows and tools like GIFT to support the creation of these types of models. So briefly, the learning effect model, for anyone who's not familiar with it, is a model that describes relationships between different components of an intelligent tutoring system architecture with an eye towards supporting generalizability and reuse and authorability. A few years ago, this model was extended to incorporate team learning and training within it, though the overall structure of the model kind of remained largely the same. But the learning effect model is really critical in the context of GIFT, since it underlies a lot of the architectural design of GIFT and how information flows within GIFT, which has implications for how data-driven pedagogical planning models should be architected and integrated with systems like GIFT. So I've created this matrix to kind of compare and contrast some of the issues and considerations and how typically issues of state and actions reward, which are really integral in reinforcement learning based pedagogical planning, how it's typically been done in the literature in AI in education, intelligent tutoring systems, and kind of contrasting that with kind of the learning effect model view of the world. I don't think I have enough time to go into this in great detail, but just a couple of the highlights here are that much like the intelligent tutoring systems literature more broadly, a lot of the work in data-driven pedagogical planning has really been focused on particular use cases and learning environments and learning objectives, and has treated the information sources that go into state, kind of the inputs and triggers to a model, as being just a broad pool of features that can be drawn upon to inform pedagogical decisions. These models are often agnostic to where the information that's coming in to inform pedagogical planning decisions is coming from. And this is really contrasted with what the learning effect model, kind of how it thinks about the world, whereas this distinction between domain independent and more domain specific features. There's this emphasis on generalizability that really accounts for how information is routed and what information is available in the pedagogical module versus the domain module in GIFT, and so on and so forth. And so there's an importance of aligning how state representations are devised for pedagogical planning so that they are consistent with the constraints and requirements of the learning effect model in order to support integration in systems like GIFT. And there's kind of an analogous issue for the pedagogical actions that are modeled in these frameworks. In fact, there's some issues of kind of overloaded terminology if you were to try and directly compare the literature on data-driven pedagogical planning and the learning effect model, where there's been work on the creation on using reinforcement learning for concept sequencing and delivering remediation and what are called instructional micro tactics. It's not always clear how those kind of approaches load onto constructs like instructional strategies and instructional tactics that are outlined in the learning effect model. So again, there's an opportunity to and a need for work on data-driven pedagogical planning to really be explicit about how it can kind of fit within a learning effect model version of the world. And there's kind of a similar issue with reward, which is what's used to drive the optimization process for inducing these pedagogical policies, and how constraints and allowances for how information flows within GIFT. So the exploration exploitation trade-off is a really fundamental issue in reinforcement learning. It's nicely illustrated by this image I have on the right here, which shows a little robot who's trying to make a decision about where to eat and must choose between, on the left, the usual place, and on the right, the new exciting restaurant that they've never tried before. So in the context of pedagogical planning, this is this balance that is necessary between choosing and delivering actions that have worked well so far in the past versus trying new actions that could yield better future learning outcomes, but also could risk being suboptimal because they're kind of exploring new parts of the space. So this exploration exploitation issue is really fundamental to data-driven approaches to pedagogical planning. And it points to a term that has emerged more frequently in the reinforcement learning literature for pedagogical planning as using policies that are random yet reasonable. So making sure that even if the logic for making decisions about pedagogical planning has an element of exploration randomness, that the actions that the pedagogical planner will select are still reasonable or are going to yield acceptable training outcomes. And this issue is even more important when there's a human in the loop kind of mediating how feedback is delivered, because then that human instructor is mediating this exploration exploitation process. And just really briefly, I won't go into a lot of detail on this, but there's an opportunity in tools like GIFT to really accelerate progress on the creation of data-driven models of team feedback, particularly through tools like the event reporting tool, by adding features to kind of streamline workflows for these types of use cases. So for example, extracting common features from logs that would be used by pedagogical planning policies, and generating data reports that are more directly, that are kind of directly compatible with external machine learning tools that for the foreseeable future would be used for inducing pedagogical planning policies. And over the longer term, I would imagine that ultimately there'll need to be some level of integration of machine learning tools into systems like GIFT. If a vision of self-improving systems that kind of, as new data is generated, it is used to drive and refine pedagogical policies as comes to fruition. So these types of streamlining and automating elements of these workflows is a key opportunity. So just briefly in conclusion, providing effective coaching and feedback to teams is a key challenge and a really interesting research area in adaptive instructional systems. Our team is actively working on investigating the design and development and evaluation of data-driven models of team feedback and simulation-based training environments with GIFT. So some of the kind of major themes that have emerged in our initial discussions on this project include the importance of the learning effect model in terms of shaping methodologies for data-driven pedagogical planning and team feedback, issues implied by the exploration exploitation trade-off in data-driven pedagogical planning, and opportunities for enhancements to pedagogical planning workflows, and specifically components of GIFT like the event reporting tool. So much of our work is future direction since we're in the early stages of this project. So one of our next steps is we're eager to begin engaging. We're in talks with WizTech, engage and be able to collect some data to observe how trainers provide coaching and feedback to teams during collective training exercises in VBS. We're very interested in the potential for GIFT Game Master to be able to help facilitate and mediate this. We're also keenly interested in recent advances in reinforcement learning and other machine learning techniques that can be brought to bear for creating data-driven models of team feedback. and over the longer term, integrating data-driven models of team feedback with GIFT in support of training management priorities for STEE. So I'd like to thank colleagues at CCDC and Dignitas and WISTIC for support and initial discussions on this project, and of course support from the Army Research Lab. I don't know how much time I have left, but if there's any time for questions, I'd be very happy to take them. Thanks for your attention.
All right, great. Thanks, John. Open it up to questions. We got time for a couple.
And of course, if anyone thinks of questions offline, I'm happy to field them in the chat or via email.
So the question I have, John, is to train these models to operate in real time, how many data points are required to feel comfortable with the initial policy set?
It's a really great question. And I think a lot of that also will depend on the particular kind of algorithmic approach that we use for inducing these models. So kind of using a traditional reinforcement learning, kind of like a vanilla reinforcement learning framework, those types of models tend to be extremely data intensive. But there's emerging work on sample efficient reinforcement learning techniques. There's kind of similarly a lot of really interesting work on inverse reinforcement learning techniques that can use human demonstrations that we're keenly interested in looking at to bring to bear for inducing these data-driven models of team feedback. Because one of the observations, kind of a major theme in a lot of our discussions has been that kind of very naturally compared to the context of individual learners, collecting really large volumes of data, which in machine learning, it's always ideal to have more data. The more data, the better. Since the learners are now in groups, there's just simply fewer data points that are available. So I think sample efficient methods and methods that can incorporate have some strong priors and prior knowledge into the pedagogical planning models that are then augmented or refined through data-driven processes is an area that we're really interested in.
All right.
Yeah, can I ask another question? Wendy, this is Hong at Burrito. I noticed that you have the human in the loop, and then what's the requirement? Is that a synchronized communication or asynchronized? If it's a synchronized, it means the human, the teacher, or the run with this simulation system. So do you have any thought or design about what's the requirement for the human? Need to be there all the time, or just to be every some period of time, like a day or a week?
Yeah, the model that we're kind of using here, and particularly with use of like a tool like Gift Game Master, is assuming synchronous communication.
Okay.
So the instructor is live and observing and kind of controlling or in providing feedback and assessments in a live training exercise, which is very common. And the hope is to be able, in a project like this, is to be able to develop automated models that could either augment or provide additional feedback opportunities, perhaps when the instructor is not available, or maybe to support the instructor for team training. But so currently we're kind of operating in a mode, particularly for data collection, where it is synchronous.
Mhm.
Though, kind of to your point, potential for asynchronous, like maybe for retrospective feedback that instructor might provide, is something that we've talked a little bit about, whether that could be an opportunity for being able to collect additional data about how to provide feedback and coaching and augment what's possible to collect in a live setting.
So to add to that, we are developing a capability to where you can kind of review a prior collected session and then adjust your performance assessments, or especially in a high workload environment. Speaking, anecdotally, we've run a couple experiments up at West Point looking at this tool, and it is a usability dream for a researcher because it is extremely challenging. So as many automated features as we can support, I think the better. But how we communicate those automated functions to a human counterpart will be the interesting aspect.
Yeah, like in the first time I saw a demo of Gift Game Master, one of the really striking things is just there's an enormous range of capabilities in the software. So kind of to your point, Ben, kind of the human factors of how to empower and enable instructors to be able to leverage them effectively is just super interesting.
Yep. All right, thanks, John. I think there's a couple other questions in the comments or the chat window, so feel free to continue. We're going to pass it over to Randy Spain. I think we ate into some of his time, but we built in a little bit of buffer at the end. So, Randy, ready when you are.
All right, I'm going to see here.
All right. Thanks.
All right, are you seeing the slides or are you seeing slide view?
The slides.
Perfect. All right. Good morning, everyone. Thanks for sticking around. As John and JT said, it's always nice to be able to reconvene and hear about all the great work being done by the GIFT community. So I've really enjoyed the past day and a half, and I'm often awestruck by some of the just really powerful work being done by other people. So I've really enjoyed it. Today I'm going to talk briefly about a new project that we're working on that's really focused on taking team communication, being able to look at it, understand it, and help drive some of these assessment processes that Greg has talked about and others have talked about. And today I'm just going to share some preliminary work that we've done analyzing and evaluating the performance of different automatic speech recognition engines. So, as many of us have said during this session, teams are fundamental to the military. And along with this, the military has studied teams scientifically for more than 60 years. The importance of teams to the military kind of dates back to the Second World War, when individuals and leaders started to realize that team dynamics and performance were noted as important contributors to military effectiveness. And since then, there's just been loads of great research looking at what impacts teams. How do we take these individuals that come from different backgrounds, different levels of knowledge, put them together, make them form this cohesive, and that's really a key word when we're talking about teams and team effectiveness and team performance. How do we get them to gel and become this kind of expert team, as you'll often see in the team literature? And just a few things to hit on here. Really what separates kind of team tasks from task work is the fact that teams are working together to achieve a shared goal, and their tasks are highly interdependent. So that means, and the best way to think of this is just to think of a sports team, something like basketball, soccer, or football, and everybody has a role. You've got your individual tasks that you're responsible for, but as a unit, you're also working to achieve a goal. And so really when we're talking about teamwork, we're looking at those, well, what are those kind of interdependent components of performance that are required to perform effectively? And we're not just talking about how many points you scored. We're talking about the processes that teams engage in. And what are those processes and how do they impact team performance? And so JT gave a great overview of the team development model and how that breaks down kind of team components into things that are kind of verbal implications of how teams can communicate, and also these behavioral aspects of looking at team performance in different ways. So this is just kind of a different representation of that. And when you think of, what do dismounted squads do? They move, you shoot, and you communicate. And communicating is key, especially when we're talking about the environment that they operate in. I mean, they're not sitting back in a talk looking at all sorts of C2 systems. They are on the field, they're radioing back and forth, and that's how they're kind of building this shared knowledge. So that whole, notion of, team situational awareness, team cognition, team knowledge emergence is critical. And you can think of teams as these information processing units for all of my cognitive psychology friends. You've got individuals that are a part of the team. And if you think of an information processing model, you're encoding information, you're storing information, and then you're retrieving information, and you're sharing that with different team members when you're a part of this kind of collective unit. And so, if you look at the literature, and there's been some really great work published recently about, when we're developing AISs for teams, the importance of looking at these behavioral markers, identifying the construct you want to assess, looking at trace data and ways to start to extract these kind of behavioral observations that are representative of those states. But then you'll also quickly see that looking at team communication is a critical piece in order to understand how teams are sharing information, how that information drives other team processes, such as coordinations. Are they engaging in backup behaviors? Are they sharing information when they need to be sharing information unprompted? That's kind of, you can come up with these different questions where you can not only look to see, well, how is communication important to teamwork overall, but also you can kind of take a look at this framework here and say, within this kind of cast over here on my left, information. Well, what can we do? How can we use this to assess team performance? And there's some key questions that you can ask. So, did team members seek information from all the available resources? Did they pass information in a timely manner? Were team members provided with kind of situational updates as events were unfolding and changing? You can look at how that information is passed, that phraseology aspect. So, you don't want to, just garble up the radio lines. You want to be precise. You want to use the proper terminology. You want to follow doctrine, and you want to make sure that it's complete information. So if I'm a team leader and I'm passing information up to my squad leader, I want to make sure that I'm doing that in the most effective manner possible. And then you can also kind of take a look at this framework and say, well, what do we mean by closed loop communication? And that's just how are we acknowledging that others have received any updates that I've pushed down the line? If I'm a squad leader or a team leader, making sure that everybody understands what their new responsibilities are if we have a shift in direction or task. So we can go through and look at, again, how communication impacts other team processes, and then kind of these emergent states like collective team efficacy, mutual trust, and team cohesion. There's actually been some really interesting work looking at the importance of team communication and team outcomes recently. A recent meta-analysis showed that, it's not what you say, it's how you say it. So communication quality is a better predictor of team performance than just the kind of quantity of communication. There's been some really interesting work looking at this notion of kind of team cognition and team knowledge emergence, and kind of the unique way that communication facilitates that development. There's the meta-analysis published a few years ago with Bob and company that looked at different behavioral markers of kind of team performance and team learning, and looking at that publication, you can quickly see the key role that communication plays in both. And I think what's really important in terms of team training is the role that it plays in team learning. And then, as I mentioned earlier, when you're looking at team communication, you can also start to gather some insights into how communication kind of influences these emergent team states like cohesion and collective efficacy. And there was a really great dissertation completed last year that kind of looked at this with data from the Squad Overmatch project. I guess what I'm trying to do here is just set the stage for how important team communication is for studying and assessing team performance. But analyzing team communication can be difficult. If you look at kind of a traditional pipeline for doing this, you'll collect data, you'll put some mics on folks or get a video camera and record things. And then a lot of what happens next is driven by human annotation. So you're transcribing communication data, you're using different coding schemes to kind of evaluate, rate, and label data. And then you can do a number of different kind of output processes to see, or you can kind of do the coding and counting thing where you're coding the data, then counting how many times certain labels or utterances occurred, and then using those to see if there's any correlations between kind of frequency or some sort of sequences of statements between team members and team performance. So given the challenges associated with this, our task really is focused on automating these different processes. And so that's the new project that we're working on with our colleagues at STTC. And it's kind of being able to automatically transcribe the data, being able to apply some automated labeling and coding schemes, being able to generate different outputs that research psychologists like myself are interested in examining to look at team performance, and then helping to align those with different outputs and outcomes that we can help to inform different deficiencies in areas where teams can help to improve their team communication. And so the project that we're working on is largely driven in that nature. Our goal is to create a deep learning driven kind of team communication analysis toolkit. We're calling it TCAT. And today I'm going to talk about some preliminary work that we've done that really focuses on kind of this first component of this pipeline here. And this is just a notional representation of the project. So being able to take incoming communication that's captured from team members and being able to kind of pass that on, generate some transcripts, and see how accurate those are before they feed into other portions of the pipeline. Next, I'm going to talk largely about speech recognition, and I'm going to just give a fairly high overview of this. But at the basic premise of speech recognition is that somebody is saying something like "I'm talking right now," and then a system is able to take that verbal speech and then output it as a transcript. And there are a number of different steps and processes that happen in between that. And this is just a traditional kind of ASR workflow. So you've got your raw speech data. It kind of goes through and is filtered in through some feature extractions. It's passed through an acoustic model and a language model, and then it generates this transcript of that speech event. So prior work in ASR was largely grounded in hidden Markov models and different mixture models. Now you're seeing that with all the advances in deep learning techniques, how these neural networks are starting to shape and form these speech recognition models. But like all things, nothing's perfect, right? And so there are a number of factors that can impact the accuracy of these systems. Background noise is a big one, and this is really important when you're thinking about being able to use speech data from simulated events and live training events. You can think of just the characteristics of that environment. And you may think, oh, well, if I'm using VBS3, I shouldn't be, have to contend with that much environmental noise, which could be true. But then you start getting into other kind of training environments. So John showed in his previous slide a picture of Wistic where they're doing some crew gunnery training, and they're pumping that theater with the audio that you would expect as you're doing firing these machine guns. So you're going to have this background noise that you'll need to contend with. Multiple speakers presents a challenge, these kind of multi-dialogue, multi-speaker settings where the system is trying to not only recognize what is being spoken, but who is speaking, and being able to accurately parse that out into these speech turns. The model that the engine is trained on has a great influence on it. And speaking of that, there's a lot of jargon in the military, and so if your model isn't trained on that jargon, it's probably going to miss or misinterpret a lot of what that is saying. There's been some studies over the past few years that have really taken a look at the performance of different speech recognition systems in different environments, and I'll just highlight a few here because I got the friendly bell. So let me know, I've got 4 minutes left. But Blanchard, this is out of Sydney's group, Sydney DeMello, they looked at some the ASR accuracy of different kind of contemporary, you can think of like the big tech companies, Apple, Google, IBM, how well their engines performed when they were trying to analyze speech recordings of teachers that just were collected in this naturalistic environment. So they had middle grade teachers, they were leading classroom activities, asking questions. There's noise happening in the background because you're in a classroom. How well did these different systems perform? What they found was that the WER, that stands for word error rate, and that's basically looking at the accuracy of the system. They're still generating a considerable amount of error when you're looking at how well they generate these transcripts. More recently, Kim and colleagues looked at ASR performance in a training setting. They compared a number of different systems again, or providers. You can see that the performance is a little better, and a lot of that is attributed to kind of this difference in the training setting. So they're actually analyzing videos of simulated patient interviews in a medical training setting. And more recently, colleagues out at ICT did this kind of update on the performance of different providers, and they used, I think, 7 different data sets and looked at a number of different tools, both using kind of online and offline processes. And one of the interesting things here, and that's relevant for this when we're talking about STI and all the different subjects that this community is interested in. Several of those data sets captured human interaction with virtual human technologies. They also had 2 data sets that looked at human-to-human communication within virtual VR training setting. And what they found was that in terms of word error rates for generating these transcripts, when they looked at the interactions with the virtual characters, those different providers were able to generate pretty accurate transcripts. But when it turned to, and it's because they were just looking at the speech between the human and the virtual character. And when they looked at the performance in the VR training setting, the performance varied much more widely and was, you notice, a lot more error within the transcripts. So really, the goal of our study here was to extend this, compare the speech performance of some contemporary ASR services using 2 different team communication data sets. And what we wanted to focus on was looking at a noisy environment and then a relatively sterile environment. And so for this paper, we focused on data collected from the Squad Overmatch project. I won't get into too much of that there, but what I will say is that we focused on speech data that was recorded from squad members as they completed a capstone training event. This was a live training mission, and that was kind of our noisy data set. And then we also analyzed the speech communication and the after-action review session, which immediately followed that mission. Just a few characteristics about the recordings. This was, even though individuals had individual mics, oftentimes, you're picking up conversation among multiple members from one microphone. So you kind of get into this multi-speaker, multi-paradigm, multi-dialogue paradigm. There's environmental noise, and in some cases, audio quality was good. In other cases, it was very muffled. Just a quick overview about the sequence of events that were a part of the training data set that we looked at. So the capstone mission, it had a squad that was conducting a kind of a zone reconnaissance. And I think what's really important here is that you've got a squad that's setting up, they're doing some observations, they're looking for a key leader. Once they confirm that that individual's in the village, then they approach and do some key leader engagements. They move through the village, they talk with some other key characters that were role players or virtual characters that were designed as part of the training event. And then they get to an event where an IED goes off and kind of all hell breaks loose. And there's some more events that happened after that, but for the purpose of our preliminary analyses, we just focused on the first 20 minutes or so of that training event. So in terms of just our process for preparing and analyzing the data, we took our team recordings, and again, this was that live training data and the AAR data. Generated manual transcripts. We were fortunate enough to have some assistance from GRAs in our group, and then to get some transcripts from our colleagues at ICT of these training events. We identified keywords, just phrases, jargon, terminology that we knew would trip the systems up. Then we ran those team recordings through the ASR engine. We looked at the performance of Google Speech, MS, Microsoft Azure, and then we also looked at Caldy, which is an open source toolkit. After the engines generated, the services generated the transcripts, we kind of organized the transcripts in a manner that facilitated our analyses. And this was basically you're dividing things up into speech segments and looking at how well different services were able to identify different speakers, and then did some analyses here. So just to give you an overview of the initial run at this, for the live training, we focused exclusively on the squad leader and the squad leader's interactions with the different characters and key leaders. We cut it off probably about 22 minutes into the training event. So it was right before the IED happened. After that, there was several minutes of screaming, which was particularly challenging for the ASR service. And for the after-action review, it was we extracted audio from the video file. That's about 45 minutes worth and about 320 speech turns. In terms of our analyses, we looked at word error rate, key spotting rate performance, and transcript omission rates. So, and what we found was that, as expected, when you're comparing kind of these two different environmental conditions, if you will, performance for the live training, the services generated many more errors. And here I've got labeled above like what our default models were for this. So for Google, we use you can choose between a couple of different speech models. We use the video and the neural one. We also looked at how well it performed just using the baseline, but also adding the keywords to that. And so we didn't find very many differences. You can look at the paper for the exact readings and numbers. And then we also, I guess one thing to point out is that quality, we used kind of the default neural model there. And it uses it's trained on a different architecture, and it just comparing the after-action review data, you see that their word error rates are much higher than the other providers, even though that it was a relatively quote-unquote clean data set. In terms of keyword spotting rates, here, higher is better. I see that Google is performing well, and I know I'm running along here, so I'll clip faster. We also looked at transcript omission rates. What we're finding is that it's the live training stuff. It's just challenging. That's the best way to summarize it. And I can provide some examples. So here we've got kind of the manual transcript and then examples produced by the different services. The first two kind of rows here are from the live training session, and so you can see, Google starts off pretty good. It acknowledges this building to where they're moving, and then some things kind of get lost in the shuffle there. I think one thing to point out is you notice some differences between kind of how I like to describe it as kind of like a sensitivity threshold in terms of signal detection theory, like how willing or conservative the system is into generating outputs. And so you'll notice that Google was a little more conservative, and that also kind of comes through in some of the transcript omission rates. And Microsoft was more willing to try to generate output, and that even at the cost of word accuracy. So just to kind of summarize very quickly, so despite the many advances in speech recognition capabilities, there's still challenges that the community needs to overcome before these types of tools can kind of be integrated into an NLP pipeline to help drive team communication assessments. Future direction. So we started to look at just some different ways to help improve the accuracy of these systems. We're doing some interesting work right now to where, we're taking more of a top-down approach and thinking about, all right, well, what part of our NLP pipeline do we want to optimize? And this top-down approach it follows largely it's like what JT was talking about. You And you can think of it in terms of a stealth assessment framework. You've got your construct or team construct that you want to assess, and then you're looking for these kind of verbal indicators or keywords that can help drive the assessment for that topic. So, and with that, I know I am 3 minutes over, so I apologize to Robert, who's up next. But I'm happy to take any questions here or offline as well.
Yeah, thanks, Randy. Just for the sake of time, we'll move on. We do have a small buffer at the end of this next presentation just for general discussion and to bring up questions that we didn't have time for. So we're going to go ahead and pass it over to Robert McCormick. You have the honor of bringing us down the home stretch.
All right. Well, let me get my screen share working here. Okay. Is everyone seeing the slides?
It's good on my screen.
Okay, thanks. All right. Well, thanks everyone for sticking around for the final presentation here, and thanks to Ben and all the organizers for putting together a really fantastic conference despite all the limitations we've had. I think this has worked out really well, and I've seen a lot of great presentations. So the work we're talking about actually fits really nicely with the work that Randy and John just presented, both in terms of measuring teamwork and the way we think about that, as well as speech to text capabilities and how we can use that as part of our teamwork analysis methods. So this is my third GIFTSYM, and this is third time presenting on this project. So the first year that we talked about this Teamwork Tutor project, I presented some scenarios for teamwork training that we were putting together. Last year presented on some of the measures that we had started to develop, specifically measures of coordination. And this year we'll talk about some extensions to that, moving into measures of cohesion for teams, and integrating some speech to text capabilities as a way to measure those teamwork aspects. So the overall objective of the work we've been doing is to develop a system focused on training teamwork skills for kind of a range of team sizes from small teams up to larger teams. We've specifically been focusing on squad size elements, so 9 people. But our hope is that our system is pretty scalable to larger teams. And we are focused specifically on teamwork skills as opposed to task work, because we know that teamwork skills are positively correlated with performance outcomes. So the better a team is able to work together to communicate, the more cohesive they are, generally the better performance we see. And, training teamwork skills can be difficult, and it's usually treated as a byproduct of kind of task training. So the hope is that as teams work together over time, they'll kind of naturally develop these teamwork skills. But teams change over time. Team composition changes, especially in the military. People are rotating in and out. So there's really a need to proactively train teamwork skills rather than kind of relying on those emergent circumstances. And the Army specifically recognizes the importance of teamwork in a lot of ways, in terms of building cohesive teams, creating shared understanding. So as I mentioned, kind of our focus for this work is on 2 skills, coordination and cohesion. Coordination is, we typically think of as a team process, the act of coordinating with each other, and cohesion is a team state that kind of emerges as teams work together. And so today I want to kind of review what's brought us here, some of the previous work, provide some updates on the measurement of cohesion, and then talk a bit about how we're integrating speech-to-text capabilities into this system. We're using VBS3. This is, we've already heard a bit about this today, so I won't go into too much detail. But essentially, we wanted to provide kind of a realistic enough environment for team training that we could, provide some realistic skills or realistic training scenarios that the team has to go through, and as a way to, provide some automated data for our analytics. And VBS3 has been used a lot with GIF, so there's already some nice connections there that we can build off of. And so let me kind of jump into the scenario we developed within VBS3. So this is adapted from the Army Basic Leader course, Combat Search and Rescue training module. So these are, typically live training events that we've adapted to the virtual environment. And like I said, we're focused on kind of a 9-person squad with 1 squad leader, 2 4-person fire teams, which each of those has a fire team lead. And the overall scenario is that there's been an F-16 has been shot down, pilot ejected, landed in hostile territory, and so this squad has been tasked with performing a search and rescue because it's in kind of their AO. So their primary objective is to locate and extract the pilot, and then they're to kind of push them on in the scenario. We've developed kind of the secondary objective of reaching the nearby village. And we break this overall scenario down into 5 independent vignettes, or somewhat independent vignettes. So kind of they set off from their camp and set down a road, and we brief them ahead of time that the area they're in has some known hostile activity, that they should expect to counter potential threats, and so they're already somewhat primed for looking out for things. And so the first vignette in here is encountering an IED. And so as they're kind of moving down the road, they spot something out of place and have to deal with a potential IED threat. The next one actually involves finding and rescuing the pilot. So once they reach kind of the last known area, they have to go out and search and find them, assess their condition, perform some basic first aid steps, and then call for a medevac. The next vignette, kind of as they continue moving, there's harassing fire from the hostile militia. They have to respond to that, take cover, neutralize the threat, and continue to move on. In the fourth vignette, we actually have another IED, and we purposefully kind of did this again, so that gives us kind of a scenario we can compare over time, their performance on the first vignette with the IED, and then on this one with the IED. And then the last one is they encounter a individual walking down the road, and they don't know the individual's intent, what they're doing, and so they have to properly address that. And here's just kind of a map of the area. As you can see, we have a start location at their camp, and then they kind of move through this linear path to the IED, to the pilot. They encounter the fire, encounter another IED, and then the civilian approaching them. So we kind of push them through this map along this road here. Okay, so how do we actually measure teamwork within this environment? So we're using a process that some of my colleagues developed for developing specifically teamwork measures that utilize both kind of a theoretical approach of understanding what do we mean by teamwork, what are the specific definitions of constructs, and what are the attributes and behaviors associated with that, and marrying that with kind of what data is available from the environment. So we kind of identify what data VBS3 gives us, and allows us to kind of marry those two to say, you know, this is how the attributes and behaviors associated with this teamwork construct are revealed within the data. And this allows us to basically develop these automated measures of teamwork, or these measurement indicators that provide some insight into that process or that team state. So we've used this a lot, and this has been very helpful in developing some of the teamwork measures here. So I won't go through all of this, but these are some of the coordination measures or measurement indicators that we developed in the previous years. And some of these are specific kind of to the particular task. Some of these are more general teamwork skills that we're looking at. So, you know, within each vignette, we've got 4 or 5 different coordination measures that we're assessing. And so, for example, in the first one, we look at, you know, when they're walking down the road and they encounter a potential IED threat, do they first recognize it? Do they halt? Do they communicate with each other? And so we measure kind of the time it takes for them to notice the threat, to stop, and for them to communicate the threat, and for everyone to stop. As they're moving, we're looking at how they maintain a close formation. Are they too spread out? Are they too close? And we're assuming they kind of have to coordinate to be aware of each other's position and keep that formation. So we're actually measuring their positions and how that changes over time as they move. We're also looking at how they maintain visual control over the environment. So are they scanning the horizon? And this is after kind of they've stopped. Are they kind of, does the team overall have a full 360-degree view of the environment to watch for potential threats? And then how do they coordinate on addressing the IED threat? So there's this notion of 5 C's, they call it, which are confirm, clear, call, cordon, control, that they're trained to do when they encounter a potential IED. And so how well do they coordinate as a team to perform those actions? And so what we're looking for is, are they selecting the right actions to take? Are they doing it in the right order? And is the team overall participating in those actions? And I won't go through the rest of these, but we have kind of similar types of measures of coordination for the other vignettes. Turning to cohesion's a little bit different because this is basically an emergent team state. And we can break it down into 2 categories: task cohesion and social cohesion. Task cohesion is generally defined, and how we're thinking of it is the ability of the team members to work together to achieve a common goal. Versus social cohesion is really how well the team members interact with each other. It's kind of thinking in the absence of a goal-oriented environment, just how well do they communicate? Do they like each other? Do they seem to work well together? And using kind of this measurement process that I talked about, one of the first from the top down side is we kind of go through literature, enumerate kind of what are all the attributes and behaviors related to cohesion, both task cohesion and social cohesion, and enumerate those. So this is just kind of an example list. This is about, a fifth of the total attributes and behaviors we came up with that we were able to find. But these are things like communicate, acknowledgement, communicate with positive replies, communicate with certainty, and things like that. So a lot of this is focused on the communication, but there are other aspects of cohesion too that we'll see. So we enumerate this list, and then kind of from the other end, from VBS, we think about what data do we have available. And so, there's a lot of data coming over the VBS bus, position of every avatar, their orientation, their stance, whether they're standing, prone, crouching, status of their weapon, whether they have it drawn, holstered, whether they fire the weapon. There's chat logs in VBS. There's other kind of customized menu commands. If anyone's interacted with VBS 3, there's a lot of buttonology to learn. And there's a lot of it's very extensible, so you can take a lot of actions, but it requires a lot of button presses and things like that. So we kind of enumerated all those data that we can get and married those into a number of cohesion measures. So I'm going to go through a couple examples here just to give you a feel. So this one we're calling No Person Left Behind. So the idea is we want team members to be aware, to be looking out for each other as they're moving. And so what we're looking at is making sure that there's not some person that has been, lost to the rest of the team, I'll say, or, has fallen behind. And so what we are actually measuring is whether or not every person in the squad is seen by someone else. So do they enter their field of view at some point? So what we don't want is one person that has, not entered a field of view of anyone else on the team. So we're basically measuring how often a person crosses a field of view of another person. And then we kind of aggregate that and look at, what's the amount of time elapsed since, any one team member has not entered another's field of view. And we can kind of assess and provide feedback on that of how often that's occurring. A second one is mirroring of stance movement. So we're looking at kind of, are their avatars standing, kneeling, are they prone? And when they're moving, are they walking or running? So what we want is, we need people to kind of be aware of other states and to be able to move in the same way. So we're assuming during particular moments in the vignettes that, if someone goes into prone, that the rest of the team should follow suit. So we're looking at the amount of time it takes for, or the amount of time it's been that any one team member has kind of been out of sync with the rest of the team. The third one is now looking at kind of the way they speak to each other. And so one of the attributes of cohesion is the use of inclusive language. So this is looking at how often they talk about the team in terms of we, us, or our, versus more exclusive language where they talk about I, me, mine. And so what we're looking at is their verbal communications, and I'll talk about that more in a minute, but doing some counts of how often they're using the different types of language in inclusive versus exclusive, and looking at the ratios of those. So this is overall for a vignette. We're doing counts of each person and how often particular words are spoken, and looking at the ratio of inclusive speech to exclusive speech. And then we can provide feedback on kind of the ratio of those that we're seeing. And then the last one is use of acknowledgement in their speech. So again, from previous literature, we know that use of acknowledgement is tied to cohesion. So how often are they saying, Roger, okay, got it. And we're comparing that to kind of negative or uncertain speech, where they're saying unknown, don't know, I'm assuming, etc. And so like the previous one, again, we're looking at kind of the ratio of these types of speech to each other and providing feedback on those. Okay, so important part of this is the actual communication and speech analysis. So previous years, we've kind of been avoiding the issue of looking at kind of their verbal communications by really looking at the actions and behaviors that they're taking within VBS 3. But as we've continued to develop these measures, it's become very clear that you really can't measure teamwork without looking at how they're speaking to each other. And so this last year, we've really been focused on developing and integrating some speech to text capabilities within this Teamwork Tutor system. And initially we were gonna, when we first started this project, we were gonna use kind of chat, either built into VBS3 or an external program, to look at how people communicate with each other. But again, going back to the buttonology required for VBS3, they really can't continue to move and take actions while pausing to type chat messages. So we really had to move towards this kind of automated speech analysis. And so we've developed kind of a microservice-based architecture for doing this. The way this works is, each of the trainees will have a headset. There's an audio recorder that's kind of constantly recording their audio. It's looking for, it's looking for moments of silence and kind of chunking the audio that way. So when it detects silence, it'll kind of take that previous speech, send it to the speech detection microservice, which is, we're not married to any one service, Google or Amazon, or right now we're just using kind of Microsoft's built-in speech to text engine, which works pretty well. But this could, easily be extensible to the work Randy talked about. We can include that here. And so, essentially we want to kind of use whatever speech to text engine is best for this environment. But ultimately what this microservice does is takes in those audio files and outputs JSON, which includes kind of the trainee ID, timestamp of the speech, and then the content of what was spoken. And within kind of the larger GIFT GIFT ecosystem, the way we're using that is we have a speech recognition interop plugin that monitors for those JSON files that are created from the speech microservice, and then makes those available through the internal GIFT message bus. And so we have a number of speech-aware conditions that can utilize that text for things like the cohesion measures I went through, looking at acknowledgement or inclusive speech. And this is pretty extensible to kind of any other range of measures that we want to use speech to text for. And another thing we've done is actually gone back and began updating some of the previous measures we've already developed. So for example, the 5 Cs that I mentioned, initially the way we were doing that is they had to select the 5 Cs from a menu within VBS, which was pretty clunky. Now we're actually just monitoring their speech for when are they saying these words, are they saying them in the right order, are different individuals participating in selection of those options. So it becomes a much more naturalistic way of measuring these. Okay, so kind of the future work, what we're doing now is working towards testing and finalizing a lot of this measurement, a lot of the architecture, a lot of the speech services, in hopes of doing an experiment this year. And essentially what we're looking at is using this overall Teamwork Tutor system to identify the hypothesis we're working on is whether or not real-time feedback during training provides better teamwork skill acquisition than kind of post-vignette feedback. So as they're engaged in these vignettes, we can provide them kind of real-time measures of these different teamwork aspects and allow them to adjust in real time versus just kind of after each vignette. But then, as a secondary hypothesis, what we're looking at is actually validating some of these measures of cohesion and coordination. So, are we measuring what we intend to measure through these? And with that, again, I want to thank Dr. Ann Sinatra, who's been working closely with us on this, and kind of the whole GIFT team. And I'm happy to take any questions.
Hey, Bob, this is Randy. That's really exciting work. Thanks for sharing it with us. For your experiments, do you have a sample or population that you're targeting, and kind of what's your? It's like a silly question to ask right now, right? Because nobody can do anything.
Yeah,
But,
so that's
like
been
in your
our
planning. Yeah, like what's the ideal case?
well, so ideally we would be working with some actual squad elements. COVID has thrown a wrench into the system where it's really hard to plan kind of any in-person training at this point. So things are kind of up in the air right now. We're actually thinking, we've got some connections with ROTC at San Diego State University. We may end up just using that population, or even just some undergrads, and provide them some kind of basic training in some of the squad tasks. But ideally, we would have folks that are already familiar with kind of basic squad tasks and skills.
And help drive the validation portion of your research goals. Are you having teams complete kind of post hoc team cohesion measures, or are they being rated by someone? Where does that kind of external validation source come from?
Yep. So that's a great question. So we'll have some pre and post surveys within GIFT. Ideally, too, we'll have some observer ratings. So some folks watching them. That's going to depend on whether we're in a distributed environment or
Right.
co-located. But yeah, hopefully we would have, at the very least, we'll have pre-post survey self-report measures.
Well, thanks again. That's really exciting work. I'd love to check it out.
Yeah, thanks, Randy.
Hey, Bob, this is Greg Goodwin. I'm curious, we've been, natural language processing is still, as Randy just said, and as we've seen time and time again, I mean, it's not even close to like a 90% solution. What do you, and this maybe is for anybody on the line as well, what do you think is the best use case or the greatest utility of that technology at the current time? Over.
Yeah, I mean, that's a great point. As we saw with Randy, there's a lot of variables depending on the environment. I mean, one nice thing here is we can control the environment to the greatest degree possible. And so ideally we'll have these, the trainees in a fairly quiet room at computers. So there's not going to be a lot of environmental noise. And, one thing we're looking at testing now or soon, once we're allowed back in our offices, is how close these people can be without kind of the speech, from one person being overheard by another. In other live environments, it definitely, the quality drops. So, and we also are not kind of, our overall assessments of teamwork are not relied 100% on the speech conditions. We're also looking at some of these other behaviors and tasks within GIFT itself to make those assessments. But you're right, it's a long way from perfect.
So it seems, so I mean, it's okay to not have perfect technologies. It sounds like you're kind of saying like the best shot is in a controlled environment, maybe where the speech recognition software has time to train up on the individual's speech patterns and things like that, as well as maybe some of the terms and jargon that they would use. And you think that's maybe the best use case at the present time? Yeah.
So anecdotally, we've gotten pretty good results just with Windows built-in speech recognition in a quiet environment. We found that, just with kind of 5 minutes of training on the individual, it improves quite a bit. And then we're also adding kind of dictionaries of particular words that it should focus on, which also helps to improve it. So if you know kind of the types of speech you're looking for, the words that you're looking for, that's helpful. The other thing is our measures are not, focused on looking for one particular utterance, but are looking for kind of an aggregate over, 10-minute vignettes. So the number of times particular words are spoken. So we're assuming there's going to be some, false positives and false negatives in there. But looking in the aggregate, some of that noise should be washed out.
Okay, thank you.
So at this point, we more or less are opening up the discussion. There's been a lot of interesting research in the team-based application here, especially across the 4 presentations. You can see some similar themes and various applications to solve these challenges. Natural language being a critical one. So from there, it's a matter of anyone on the GIFT team. Do you have any comments that you would like to express that you haven't had the opportunity to? Anyone participation-wise have any pressing questions or ideas that they want to express? This is a free-for-all, and it can go as long as people want it to.
So, hey, Ben, this is Randy. I had a question, and this kind of gets back to Elisa's presentation, and maybe this is a question for Mike. So when we're talking about the walkthrough of authoring scenarios, like VBS scenarios, we mentioned that, it's great to create an outline. And I didn't know if there's a way to where you can start to create an outline in maybe Google Sheets or create some sort of format that GIFT then is able to ingest. So as you're starting to develop your first formal outline, maybe there's some initial structure formatting that you can use, and you can cut down on some of the copying and pasting that goes on, or if there's just some sort of workflow management way to kind of assist with that portion of the authoring process.
Let me see. I'm just going to pull up the DK authoring tool, and it might help with the conversation.
Yeah, I mean, I think over the next year, we've already started talking about how do we automate the task structure in a DKF with templates and authoritative sources and competencies. So that conversation has started this year, and I think over the next year, leading to the next release, we might have the opportunity to start defining, different ways where you can import from CSV files or whatever. You might be able to import these task models where you can, at least at a minimum, have that task concept hierarchy defined, and then where can we take it from there is something that we could discuss. But yeah, I don't think it wouldn't be difficult to do that. And then furthermore, this whole task structure is defined by a schema, an XML schema. So it's already available for other tools to help define that initial structure and then import that into the authoring tool.
So, the point that I was also going to make is, we have the ability, we're producing the ability to do concurrent authoring. So the hope is that you can have multiple people interacting on this page at the exact same time. So from my perspective, this in itself can be a planning tool. You have the ability to start to associate all the tasks that you want this scenario to potentially trigger. And you can really kind of storyboard out from that aspect. As Mike was saying, part of it would be eventually having some task templates, based on the mission essential task lists and things of that nature and how they link to training objectives. So we're going to try and automate some of this, but from a brainstorming and kind of build out perspective, as Mike said, streamlining some of those import functions would be great, but I wouldn't shy away from using the tool itself.
Great, thanks, Ben.
Yeah, and if there's any usability comments, feel free to post them on the forums or email anyone on the team directly.
Okay, any more questions?
Question. From a developer's perspective, is there any kind of registry that says who's doing what development-wise?
Yeah, let me reshare my screen.
Kind of like, it'd be interesting, kind of like this symposium was organized, it'd be interesting who is or
So you're coming through a little bit distorted, Randy. In terms of the support we have for developers, I covered this a little bit at the intro, but I believe that would have been probably around 5 a.m. your time. So under the gifttutoring.org wiki framework, we do have an active forum that whenever a post is generated, it essentially blasts majority of the Gift government team and development team their inboxes. So we're pretty good on monitoring and responding to these issues. As well, we keep documentation that's accessible through the wiki homepage, but it also is included in the desktop download. I believe it's just a documentation folder in the root of the Gift directory. So if you come in here and you click in you have a developer guide that is relatively extensive. It breaks down how to use existing training applications, how to integrate with a new training environment, how to build a new assessment condition. So there's a lot in here, and like we were saying, if something isn't covered, check out the forums, because a lot of issues have been raised and resolved there, and then you can always strike up a new conversation. Hopefully that's what you're asking.
I think I heard him ask, and Randy, correct me if I'm wrong, that it would be nice if you could tell which organizations are working on different parts of Gift or what features are being developed or researched. Is that what I heard?
Right.
Okay, well, that's a do out for us. We can start to at least generate some of that kind of ontological webbing on who's doing what and in what domain. Greg Goodwin presented a little bit of a roadmap in his presentation earlier that highlights some of our near-term objectives, and I think that can be a starting point where we can connect some dots. Anything else?
Hey, Ben, I thought the meeting went really well on Teams. I was just wondering, other folks, I guess we can vote on it after the fact, but there are a lot of advantages to doing it this way. Certainly saves people a lot of travel time and everything else. So I imagine we may incorporate Teams into future meetings, face-to-face meetings as well.
Yeah, absolutely. I think having a much broader reach on a venue of this nature pays dividends. Anybody out there, have any interesting areas of research that they're starting to at least consider adaptive training or intelligent tutoring system applications, or any anecdotal thoughts about, where this technology is going with the current state of the world, both at the K through 12 level as well as at the professional development level. Distributed training and distributed education, I think is starting to, grow more and more in terms of its utility and importance to society. So I'm just curious to hear what people's thoughts are from how COVID-19 is impacting their world. So the one downside to Microsoft Teams is I think it hampers engaging conversation. That would be my con.
Hey, I have a comment on this thing. So we're kind of in the process, in the spirit of resilience, of actually trying to run one of our first post-COVID or post-onset of COVID, I guess, data collections. It's in a K-12 context, but we're working with teachers to run what would have been a classroom study in a public middle school, and now would be a fully remote, both kind of regular classroom study with pre and post testing, and this we're using one of our game-based learning environments that we've developed for science education. The subject area is middle school science education, and we're actually planning to run focus groups, and we're planning to run this in the next couple of weeks. But one of the kind of takeaways from the experience of preparing for this, at least in a K-12 context, is one, that teachers are really eager and open to having interesting kind of educational technology and learning materials that are richer than online worksheets and kind of drill and practice types of exercises. And delivering through the web is just so critical. So like at least in our part of North Carolina, some of the local school systems have been distributing Chromebooks, particularly to families and students who don't have necessarily access to their own computing. So being able to deliver everything through the web, which in our case for game-based learning environments is requiring some re-engineering of things. But so far it seems plausible or feasible. And then there's also, of course, all sorts of implications in terms of adjusting IRBs and moving to electronic consent procedures for research and so forth. But I'm at least feeling kind of cautiously optimistic based on this initial experience about still being able to make progress, but it does take some adjustments in this world. Fortunately, the teachers that we've been working with have seemed really enthusiastic and are great partners in trying to make this move forward. So I'm hopeful.
Thanks for that perspective. Well, I mean, the agenda called for a 12:15 stop, so if nobody else has anything to contribute, we can go ahead and bang the gavel and call a closing to GIFTSYM8. I really appreciate everyone's participation, and we couldn't do this without you. The proceedings, I think, carry a lot of weight into how we consider new development tasks and modifications pushing forward. So we're excited to continue the work. A lot of our efforts are in the team-based domain, but I think I mentioned this in my paper. You can't ignore the individual in that aspect. So, you know, GIFT will continue to evolve, and we're excited to hear how everyone's using it moving forward. So expect another call for participation in the January timeframe of 2021, and hopefully we'll actually be able to meet in person as well. So with that, if anybody else has anything to say, I'll open it up and we can close it out.
John, I sent the follow-up. Great GIFTSYM, by the way, Ben. Thank you for running this. Ben and Elise, I know Elise, you've been involved significantly in the back end here.
Yes, a big thank you to Elise. Thanks for bringing that to attention. All right, thanks everyone.
Thanks everybody.
Thanks.
Thanks. Bye.
Thanks.
Bye, everybody.
Thanks.
Bye.
Bye. Thank you.
Thanks, guys. Bye.
Many thanks. Bye.
Thank you all.
Thank you, Ben. Elise, Mike.
Bye, Jody. I didn't catch you, sorry.